expert at CloudTech. And in this session, along with me, you have my colleague Nehal, right? Who will be there with us in the session in case if you have any query, you can drop your queries in chat and you will get a response for the same. And in case you want to unmute and you want to ask your questions directly, we can answer your questions if you have any. And apart from that, a small info about my organization, CloudTech. So I'll just open CloudTech, a company which won 2 awards in the year 2024, right in a row, right? So partner of the year in 2023, 2024, we received that awards. And apart from that, we work as a consulting and training partners with AWS. We work as consulting and training partners with Microsoft, and as well as we are a training partners and authorized instructor for CC. We work across all three clouds, and we are in this business since last 30 years. Right? That's a small intro about my organization. And let's quickly begin with the content of the day. AWS Cloud Practitioner Essentials. All right. So let me quickly bring the content over screen. And what we are covering in this content, let me just bring it over a screen. So
Hi Kamlesh, just one question. Is this session recorded?
uh, no, the session is live and recording is not allowed as per the compliance. So it will be live interactions there. Okay,
Thank you.
and I can see the voice is very low. So is it for everyone, team, or I'm clearly audible?
Yeah, it's a bit low,
Yes,
but
you can.
it's manageable.
Okay,
Yes,
so
we can
just give
hear
me a
you.
second. I'll check what else I can do. Just give me 1 second there. Okay, how is it now?
Oh, it's
Better?
better. Yeah.
Awesome, great, thank you. So let me bring the slide over a screen. Second. Okay. Great. So I hope my slides are visible. And in this Cloud Practitioner Essentials, we will be going through the fundamentals of AWS services. It's the first stepping stone. If you enter the world of AWS, the first course that gives you idea about what is AWS, what benefit AWS brings as a service to the customers, and the fundamental services, compute, networking, storage, security. That will be discussing and exploring in this journey of AWS Cloud Practitioner Essentials. In this journey of Cloud Practitioner Essentials, let's see what content we have. So you can see the course overview. We have 10 modules. Last modules is with respect to the practitioner basics, right? In case if you want to clear your exam, what things you can refer. And in all, we have 9 modules. So we start with introduction to Amazon Web Service, what is AWS. Then we talk about the compute facility in the cloud. So what are the compute facilities we have in the cloud of AWS, right? And moving out, we talk about cloud. With the cloud nowadays, we can reach the customers in minutes, right? Even though our customers are available globally, we can reach the customers in minutes with the infrastructure and reliability that cloud provides you, where you can scale yourself, you can scale your resources as per your need, and you can have the agility as well in the cloud. Apart from that, we'll talk about the networking. In case if you want to set your own small network in a cloud, where you can run your resources, which services can help us out. If you want to store your data in the cloud, which storage service can help you out? And in case if you want to run your database in the cloud, what options we have to run the databases in the cloud. So that's module number 5. So you can see compute, network, storage. As I mentioned, we have the fundamental modules of the cloud here. And then we have security. So how we can secure our account. And since cloud, everything is managed by a cloud provider, but application is our tool that we are running in the cloud to serve our customers. So definitely we need to make sure that how the services that we are deploying in the cloud for the customers working. So we can monitor that services as well as we can run the analytics on the logs that is generated by our services in case if there is some issue. Apart from that, what are the different pricing options and what are the different support plans you have with AWS and what are the ways you can migrate to the cloud, right? And how with the help of serverless services you can innovate more and put more efforts on developing your application, serving your customers with services rather than managing the infrastructure. Right. That's all we have in the course agenda. Getting familiarized ourselves with the first stepping stone in the journey of AWS Cloud, AWS Cloud Practitioner Essentials. Okay. So let's begin with our module number 1, Introduction to AWS Amazon Web Services. So I'll just end this module and I hope the outline is clear and I can see a hand is high. Yes, Zafar. Any
Kamlesh,
query?
we will have
Zafar?
access to this deck. Will we have access to this deck after the training as well?
No, the deck is not provisioned, but in case if you want to refer the resources again, I can share the skill builder link that you can refer for the
Okay.
same.
Thank you.
Okay, sure. Fine. So let me bring my first module, Introduction to Amazon Web Services. First module in the journey. And let's see what we have in this module. So since we start with the first stepping stone, we'll see that what are the different cloud computing deployment models are and what benefit a customer gets, right? If a customer jumps to a cloud rather than managing the infrastructure on premise, right? So a fundamental module familiarizing us with the concepts of the cloud and its deployment models. So let's begin. Right? Top what we are covering, cloud computing deployment models and benefit of cloud computing. That's a model topic that we have. So let's begin with the cloud computing deployment models. So if we talk about cloud, anyone can put some light. It's the most popular nowadays, the cloud infrastructure. So anyone can put some light. What is cloud computing?
It's a data storage, portable data storage, which can use for the multiple servers and multiple places can use.
Awesome. So it's kind of, you say it's a storage service, right? So you can be used by multiple servers there, right? And it can scale as per your need. So if you talk about cloud computing, what is cloud computing? Cloud computing is availability of the resources. When we talk about that resources, as Tarun mentioned, storage, right? I get compute power, right? I can get databases. And all these services, the fundamental IT services, are available over the internet, right? And I can see the same message right from in the chat from the Swapnil. Great, thank you, Swapnil, for that. Shows the availability of the IT services over the internet, where we can directly use that IT services without provisioning the infrastructure. Today, I require a machine with 32 CPUs and 64 GB RAM. I can have it. It hardly takes a minute for me to have such server. And that's possible with the help of cloud. Availability of the services over the internet. Before moving ahead, let's quickly see in this journey, we'll make a use of coffee shop as an analogy, right? And before we talk about the client server model, let's understand the analogy with client server with the coffee shop. Now, in the coffee shop, we know that we have a barista that provisions the coffee. and we as a customer go and we order the coffee there. So we order the coffee. So we send the request for a coffee to the barista. Barista, based on what you ordered, it gives you that respective coffee, right? So client server model is also dependent on this particular fundamental where we have a client and we have a server. Client makes a request for a service and server provide a response back. So a request and a response. So it's similar to a customer in a cafe and a barista. We have a client server, if I take analogy, right? And to understand the concepts, we will make a use of coffee shop and its analogy we utilize to discuss some technical concepts again. Now moving out, what is cloud computing? As added by Tarun, by Swapnil in the chat as well, availability of services, right, over the internet. And if we go technically, it's availability of services, right, on demand. Whenever you need, you can get that service, you can access that service, right? And to access that service, you don't need to make any capital expenditure. We can get that service on the go, on the fly in few minutes, right? And apart from that, for that service, we only pay for the time we have used that resources. So as I mentioned, if I require a machine with 32 CPUs and 64 GB RAM only for an hour, I can get that machine and I pay only for the charges of the hour. So it's the availability of services without making investment as a pay as you go model, right? And you get the resources as per your need. That is cloud computing, availability of IT services on demand over the internet without provisioning the infrastructure. Yes, P.
Uh, are you mean that you are getting these hardwares only through the internet?
We get
access of-
services. We get
Yeah,
services, not hardware.
services means what type of services you are getting over there?
If you require a server to be provisioned, you can get your compute facility to run your computation task in the server. You want to store a data, you get the storage facility as well. And for computing services to communicate and to serve you, you also get the networking services and the databases also that you run on premise for your application. You can run that in the cloud.
Let me some breakdown more this one. Suppose I have one Cisco server and I'm placing that all this capacity and installing over databases, OS and multiple windows and placing that access to the internet. Is that mean that all?
Exactly.
Those storage Windows servers and any like application server like JBoss, Tomcat, and we have. So we can install there and we can publish into internet. Is that the type of only services it's providing?
Exactly, right? So if you want to create your application, right, you have a Tomcat server, right? You have a Cisco server that you want to run. So rather than running it on the physical hardware, you create a virtual machines, right, in which you can install your application and you can run your workload as you are running in your offices, in your on-premise data center.
Yeah, but end user, as we are getting through the internet, so we are thinking just like it's software or it's giving as the internet interface. But at the deep bottom, we should have somewhere some hardware, any server hardware. It's provided by either Verizon, Cisco, or some other server provider. They should have those configuration already ready. So then only we can access through the internet, right?
Exactly.
If I'm not wrong.
Exactly. So hardware is managed by the cloud provider. In that case, it is AWS, Amazon.
Okay.
Right. So cloud is basically the virtualization technology, right? So I can deploy cloud in my on-premise data center as well. We term it as a private cloud, where I can use that virtualization technology, right, by using the virtualization tool in my on-premise data center. But what is the difference here? I deploy a cloud in my on-premise data center, and along with that virtualization service that I have, I am managing the physical infrastructure as well, the servers, the networking component, all those things I manage. So that's my private cloud. And
Okay.
if I want scalability, I don't want to manage this physical infrastructure on premise, but I want the services of the cloud, compute, networking. In that case, I can go to the cloud providers, the giant of public cloud providers. We have AWS, we have Azure, we have GCP. They also provide us cloud-based services, but here we get the services, but the infrastructure management is done by these giants,
Okay.
Amazon, Azure, or GCP. So they are managing the underlying infrastructure for us.
Yeah. Okay.
Okay.
Yeah.
And in case if you require that you don't want public cloud, you don't want everything on the cloud, you in the public cloud, you don't want everything to be managed by you, you can also go with a hybrid solution. So some part of application is running on premise, some part of application is in the cloud. So you see that what kind of deployment model you require, whether you want to use public cloud, you don't want to manage the infrastructure, or you want to manage the complete infrastructure, create your private cloud, or if you want to extend your private infrastructure without making any investment, you use a hybrid model, which is public cloud, services of public cloud, and your private cloud that you have. So you decide what is the model that is suitable for you and run your infrastructure over a cloud. Okay, is the idea
Yeah.
clear?
Okay. Yeah. One more question here. So this cloud provider, these giants are there, right? AWS, Azure, GCP. Previously, we used for I have used already in Cisco server. We used a hypervisor, and based on that, we are giving services to different deployment team. And those teams, they can deploy their application into those servers with help of the hypervisor. They will feel like we have the separate servers, but it's underlined that there is only one server. So it is the same thing they are doing. Our cloud is some different software which is now we are using.
It's exactly same as I said. Cloud also use those virtualization tool, as I said, hypervisor. What hypervisor does, underlying physical server you have. So we have a physical server, and to make sure we utilize the server up to the full capacity, we use hypervisor as a software layer, right? And then each team can create its own VM. Same is in the cloud. Same is there in the cloud. They have this virtualization that manage the physical servers. And on this physical server, you can run your VMs for your workload.
Okay. Okay.
Okay.
Yeah.
Fine. And here you can see on the screen, we have a dashboard of a cloud. So whenever you log into the AWS, you'll be able to see that page. So if I go to the landing page of AWS, you can see the console from where you can access the AWS services. And if you want to run your workload as well, you can run your workload on cloud, right? So it's taking a little longer. Let me see.
Hi, Kamlesh. Can you please rerun again because my screen got stuck.
Okay, I'll just share it once more. Just give me 1 second. Okay. Nilesh?
Yes. Now it's visible to me.
Sure, no problem.
How you go into this dashboard?
Yeah, so to get into this particular dashboard, you can sign into the AWS account, right? So either you can create your own account, or if your organization provides you access, you can sign in as a IAM user. So I'll talk about that. But if you need to log in, right, we can simply go to the page console.amazon.aws.com. And once you get on that particular page, you get the option to sign in as an IAM user who perform daily tasks, right? For example, you deploy the application, you inspect the services, right? So you perform the daily tasks. So you can sign in as an IAM user, or if you are owner of an AWS account who created that account, you can sign in as a root user. So we'll talk about that. So that's a console from where we can log in as a owner of our account or as a user of our account, which is getting the job to perform the daily task. Okay. So I'll talk about that in some time. We'll see that security module, right? There we'll see that how we access the console as well. I just wanted to show you how the console looks like when you sign in there. Okay.
I have
See,
another one question with me.
sure, Nilesh.
As earlier slides, what will be the as perspective of certification, how the question will be phrased related with this? Any inputs you can give? If any questions related
Questions related to.
question will come this slide with what kind of cloud
Guys,
computing getting used like that.
So you're
guys,
talking about
let's
questions in the exam.
Yeah. Yes.
So in the CPE Cloud Practitioner Essential exam, right, you don't have this question, what is cloud computing and all. You generally get the questions with respect to the services, right? For
Right.
example, you want to configure a Tomcat server, right? And you need to make sure that you need to save a cost on Tomcat server. So where you can run your Tomcat server, right? Which compute facility can help you out. So you have questions based on the services. This is just the first module to bring all members on the same page what is cloud and what benefit a cloud brings there. So module 2 onwards, you'll see the services in which we get the question. And if you need, I can bring some questions as well for discussion there. Right. So I think my colleague dropped the sample question in the chat. You can see which of the following AWS service is used to store and retrieve any amount of data at any time from anywhere on the web. Right. So you have questions based on the services of AWS there.
Okay. Got it.
Okay. Right. So you have seen how the model, how the landing page of AWS looks like. I have just showed you that. We'll talk about more how you can get access as well. Let's talk about the benefit of a cloud computing, what benefit you get with the cloud computing. So first benefit that you get, you don't need to make any capital expenditure, right? You simply start using the services and the amount of services that you use, you pay for the same, right? So we don't need to make any upfront expenses to buy the infrastructure. The infrastructure is there with the cloud provider. You just demand which services you require and how long you want to use that services. Pay for that. So we can have variable expenses rather than upfront expenses for the resources that we use. Apart from that, there is cost optimization as well, right? So how the cost optimization is there? Now I don't need a team to run the data center that I was running, right? Because now this entire part is managed by the cloud provider, right? My job is to run the services, develop the applications over the infrastructure that is provided by the cloud provider. I don't need to worry about the physical server when its hard disk is going to fail or when I might have an issue with the power. Now everything is managed by AWS. So we can focus more time on building the application. We can optimize the cost there by quickly releasing the application because we don't need to put heavy lifting that we were doing in running the data centers, right? We don't have to put that particular time. So we can optimize the cost as well. Apart from that, now we don't need to guess the capacity. Previously, if I was running a data center, I need to predict, I need to project what will be the requirement of the infrastructure for my applications to run in future. Because to set up the infrastructure, it takes a period of few weeks to months, right? And we can't wait for that time for our application to grow. But with the cloud, you don't need to guess capacity. Today, you require one virtual machine to run your workload. And tomorrow in the night, you get familiar and require today, tomorrow you require 20 such machines to run your workload. You can get that within few minutes. You can get those kind of machines infrastructure for you. So you can scale as you need. No need to guess the capacity, the requirements that you have for your infrastructure initially, right? Because cloud is scalable and you can get the elasticity in the cloud for the resources that you want to utilize, right? And with the cloud, especially with the public providers that we have, the public clouds, we have AWS, right? Such as Azure or GCP, right? Now, these cloud providers, right, having a huge number of customers, right? Already huge number of customers running their workload in the cloud. And AWS created the infrastructure at a huge level, right? It has its reach globally, and due to which they were able to set up their data centers at a lower cost, right? And they provide the same benefit to the customers. And due to they have a large customer base, they can provide the same services to you at a comparatively low cost compared to if you create such data center yourself, right? They already have a huge customer base, and due to which they are able to offer the services at a lower cost, right? So benefit from customers aggregated usage, right? That's been given to the customers. Going out further, you can increase your speed of development. As I mentioned, we don't need to wait for week for resources to get available. Within few hours, you can get your resources in the cloud computing, right? So that's a benefit that you get. You can go global in minutes. Now, if your customer base is in US, you want to deploy your application for US customers, you don't need to worry about anything. You can just go to the cloud, select the region of a US and deploy your application in the US for your customer base. So here you can see that the reachability of a customers, right? Cloud across the globe. So I can go to US, I can go to US East, US West. In the Asia Pacific region, AP Northeast 1, Northeast 2, Singapore, Seoul, Mumbai, Tokyo, you can see most of the regions are there. We have the reachability of a cloud. So if I go to the global infrastructure of AWS, we can see the reach of AWS across the globe. So over the map, you can see AWS has already covered the globe with the services that they provide in various different regions. And still it is expanding. You can see we already have a blue dots where the regions are already established, and we also have a red dots, right, where the region will be coming soon, right? In Germany, it is coming up. In Chile, it is coming up. And Saudi Arabia, it is coming up with the new regions there. So if you want to reach globally to your customers, you can run your workload across the globe and you can reach there in minutes. So if you're ready with the plan, you can reach your customers globally in minutes, right? So all these benefits the cloud provides you. And apart from that, when we go with the cloud practitioner, we'll see the core categories, right? Compute, database, network, security, storage, and also management and governance, how we can apply uh, the control or the workload that we are running. So we're exploring some of the services from these categories to understand the AWS services, how it runs, and also that's a first stepping stone to get ourselves familiarized to AWS. Okay, so I hope the idea is clear, the three different deployment models that we get: private cloud, public cloud, or a hybrid that you have, and the benefit it brings to you. You can go global in minutes. You don't need to guess capacity. Okay, why global infra is required? Is it for the latency slash performance? Yes, of course, because if I run the server in Indian region for the customers in US, right, definitely there will be a latency. So it will be great to run your application closer to your end users who are actually going to use your services, right? So to improve the performance of our application and to reduce the latency, we have the availability of a cloud across the globe. Okay. So let's quickly have a knowledge check. So what is cloud computing? So what do you feel? We have talked about the cloud computing. So which option you feel is correct as per the content there that we have discussed? Right. So I can see the correct answer appearing in the chat is the on-demand delivery of IT services over the internet based on your need. Right. So that's option C. Great. let's go to the next question. What is another name for on-premise deployment? So we say that I deploy the services on-premise, right? I use the cloud
Pri-
in my on-premise environment. So what is another name for the same? Testing. So I can see answer again appearing C. So it's very, very difficult to differentiate there. So that's right. I can see C started appearing. So it's private cloud deployment. So you can run the cloud in your on-premise data center as well. We say it's a private cloud. Or if you go with the public cloud providers, right, where infrastructure is managed by the huge joints like Amazon, right? That's AWS, right? And the next question, how does the scale of cloud computing, right? How does the scale of cloud computing, the cloud global cloud providers that we have that help you to save the cost, right? How you are able to get the services at a lower cost with the cloud providers. Awesome. I can see the correct answer appearing in the chat because they have a global huge customer base available across the globe and they are able to deploy the resources at a lower cost and due to which they are able to offer the services at a lower cost. Right? So the aggregated cloud usage from the large number of customers result in lower pay as you go prices. Right? That result in lower pay as you go prices. And that completes the module for us, right? Where we just talk about the cloud, what benefit it brings to us. So I hope now all of us are on the same page, what is cloud. And in case if you have any query, do let me know. If all is good, we can go to our next module, that's compute in the cloud. So all good, team? Awesome. Great. So let's begin with our next module. I can see hand high. Okay, fine. So let's begin with our next module, which is compute in the cloud. And team, I think I forgot to mention about the breaks, right? We have the session for 4 hours, right, from 7 p.m. to 11 p.m. Right. So what we'll do, we'll have the session for around 75 minutes, right? 1 hour, 15 minutes, we'll have a session and then we'll go for a short break of 10 minutes, right? So every 1 hour, 15 minutes or 1 hour, 20 minutes, we'll have a short break of 10 minutes, right? Where we can move and we can grab a cup of tea or a coffee, right? So that's how we'll be having 2 breaks in between the session, right? One break is around 8:50 and the next break that will have around 9:45 somewhere. Okay, so 8:50 and 9:45, we will have 2 breaks of 10 minutes there in the session, right? So I forgot about breaks to mention, right? So that was the break time that we have in between. Okay, let's begin with our module number 2, which is compute in the cloud, right? And what we are covering up in this particular module, we are talking about the compute services that we get in the cloud. So the first service that we have is EC2. So we'll talk about EC2. What is EC2? EC2 stands for Elastic Compute Cloud that allows you to run your virtual machines in the cloud. Cloud provides you different kind of machines, as we know that when we buy a machine, right? For example, if I want to buy a laptop, I know that I'll be doing a development task in that. So I'll make sure I require at least 8 GB RAM and maybe i5, i7 processor I require there for my daily job because I want to do the development as well. And if I need to buy the same for my son who need to play the games, all right, and nowadays we know that the games are a little bit heavy. So I need to make sure that if I buy a laptop for my son, then I will make sure my laptop has also a GPU in it so that the game can run smoothly, right? So we buy the machines for different work. They have different uh, requirements, right? of the resources there. I might require GPU, I might require i5, i7, and more. I may require more RAM there, right? So we'll talk about different instance types as well. As per the workload, I may require different kind of machines. Apart from that, billing options that you have for the virtual machines if you run in the cloud, how you can save the cost, right? We'll also talk about scaling. That's a feature that cloud provide to us. Scale your resources based on the need, right? We'll also talk about load balancing, how we can balance the load across the machines, right? And we talk about the services. Nowadays we use microservices, right? And we want to send messages across the microservices. We want to send the notifications. We want to decouple the microservices. We'll talk about messaging services, SNS and SQS, right? And we'll see other compute options in the cloud that is available that you can make use of. So let's begin. Let's talk about the topics, right? Whatever we have in the objectives, right? That's what we have in the topic. Let's begin. And let's talk about the EC2 as a service, right? So EC2 helps you out to create a virtual machine in the cloud. And if I create a server in the cloud, I may have a clients. So we have the same analogy, customer and barista for the client and the server, right? So if you want to create a server in the cloud, EC2 is one that can help you out. So EC2 is a service that can help you out to create virtual machines in cloud, and you can access these machines securely, and even you can resize your virtual machines. Today you are running a virtual machines with 2 CPU and 4 GB RAM. Tomorrow you require maybe 16 CPUs and maybe 64 GB RAM. No problem. You can resize your servers. And you can get these servers, you can boot these servers in minute, and the amount of time you use that service, you pay the cost for this, right? So let's quickly see that how we can run the virtual machine in the cloud. It's very, very easy. Launch and configure your instance. So launch your instance, connect to your instance, configure it. And once you do that, you can use the server to serve your client. Okay, so what I can quickly do here, I can get into a console, right? So I'll get into a console, and in the cloud of AWS, if you want to go to a service, you want to jump to a service, right? That's my landing page that I have, uh, the console of AWS. And if I need to go to any service, of course, I can go into the categories here, right? And I can look out the service compute, and I can select EC2. That's one way. Or you don't want to get into that detailing, you just want to get the services. Just type the name of service as I said EC2, and here you can see it is filtered out for me the service name. So that's my friend, a search box that can help me out to get the service quickly. So I'll quickly get into EC2, right? And what I can do there, I can simply say launch an instance, right? So I'll say launch an instance. Here you can see the instance is getting launched. I can give a name, say that this is my server. You select what kind of OS you require, what kind of machine you require. We'll talk about that. And to get into a machine, we use a key pair to log in, right? Rather than username and password, right? That we have a regular way. We make a use of key pairs, which is more secure. And let's keep everything default, and let's launch a machine, right? So I'll select everything as a default and I'll launch my machine. And you can see that I launched my machine at 7:41. And in a minute, we'll see that the machine is in the running state, right? You can see machine is in running state. And the check is going on. And within a minute, you will see the machine is available to, right? Within a minute, a machine is available to me. I can connect to this machine. Okay. I can connect to this machine. You can see I'm connecting a machine here. And once I connect this machine, I can install an application on it, right? So let's quickly see. I'll just install simply a Apache server here, and I'll see that are we able to run the HTML page on this Apache server there. Okay, so what I will quickly do, I'll run a command simply here, sudo yum install Apache server. Okay, I'll just do that. And apart from that, right, it installed that Apache server for me. And what I can quickly do here, I can start this Apache server. So I can do sudo systemctl. I'll just check the status. So it's in the stop state. I'll just start this Apache server. And I'll just update my page. Right? I'll just update my landing page. Right? So I just configured my server. I'll copy the public IP of my server and I'll drop this in the chat. Then you can check it out. Is it running the machine? And are we able to see the landing page? On the IP, I just shared the link in the chat. And let me just open that particular page. You can see in 2 minutes, we are able to see the landing page here. Right? So you can see the landing page on the virtual machine where I configured my Apache server and we can run any application, right? So launch your instance, configure your instance and provision the same. The website is locked. Is it? Team, the website is not accessible.
Yeah, it's blocked.
Is it same for all the members team?
So basically, it's blocked because of the TechM policy, I believe.
Yeah, because of the TechM policy, it basically blocked. Yeah.
Or you can open this in your mobile phone as well. It's hardly 4 digits we have. So you can open that in your browser of your mobile phone. You will be able to see that, right? And just give me 1 second. It's raining heavily in Mumbai. So just give me 1 second to close the windows due to that noise. I think maybe there is a glitch. Just give me a second there. Okay, I'm back and I can see update from Bharat. Bharat is able to access and you can access on the mobile as well. I can see the update, right? So you can see in few minutes, you can have your virtual server running in the cloud and you can configure your application in that virtual machine, right? So that's the beauty that we have with the cloud. We can get the resources deployed in few minutes, right? So you can run the resources that you require in the cloud in few minutes. That's the beauty that we have. Now, I said I can run a virtual machine and I can get the different kind of machines as well, right? So let's understand different EC2 instance types, all right? So again, we have an analogy of a coffee shop. Now I have an employee. Every employee can do any work. An employee can work as a cashier. An employee can make a coffee. An employee can fill up the inventory. So every employee can do this particular task. There is no problem. But when we are at work, right, we want to make sure that every employee does the task for which it is more suitable or more efficient. So rather than making an employee to work all the job, make an employee to do one task with efficiency, right? So here you can see, I just make sure that every employee just perform one job. And same as in the IT, I might want to run an application, but application may have different needs. Sometimes I required a balanced compute and memory. I can go with the instance of type general purpose that gives the ratio of CPU is to memory in 1:4. So that is the ratio of CPU is to memory with general purpose instances, right? So if you want a balanced amount of compute and networking, I can quickly go into the instance types in AWS. And when you go to the landing page of instance type, first option we have general purpose. And if you see different kind of machines we have here in the category of general purpose, and here you can see the ratio 1:4, 2:8, 4:16. That's the ratio of the compute and the memory that we have. If you need more compute power, you can go with compute optimized instances, which provide the ratio of compute is to CPU, CPU is to memory is 1:2. So one CPU against 2 GB memory, right? If you need more computation power, go with compute kind of instances. If I go back, you have different instances here. You can see 1:2, 2:4. Similarly, you need more memory, go with memory optimized instances. That provides you ratio of 1:8. One CPU against 8 GB memory. So you select what kind of compute power you require. You require a support of GPU. You want to run some machine learning task, you require the support of a GPU. Then you can go with accelerated computing that also provides you the GPU support, right? And you want a higher performance on the secondary storage, right? You want to store the data in the secondary storage with higher performance. You want more IOPS for the secondary storage. Go with storage optimized instances, right? So you have a different categories of instances available to you, and you select based on your workload requirement. And of course, sometimes we don't know what is the kind of compute I require. Maybe I cannot guess which machine will be suitable. I don't want to get into documentation, search all these things, right? I want AWS to tell me that what kind of machine can help me out. So when you launch your instance, all right, I'll quickly click here. Here you can see in the instance type, you have an option to get an advice. Okay, you have an option to get an advice. So if I say that get advice, right? Workload type, what you want to run data warehouse, you want to run NoSQL, you want to run ETL workload, you want to run Hadoop file system, you select what you require. So maybe I want to run web server. What is your use case? Are you doing web hosting, gaming, CDN network? What you require, you select it. And based on that, it gives you the suggestion. You want high performance, you want low cost, because machine might have different cost as well. So I'll say I want low cost container delivery network to be created, and any CPU requirement. Are you preferring Intel, AMD, Graviton, or Mac processors of Apple? Do you have any requirements? If not, just say get instance type, and it will give you that particular option, right? Which machines can help you out with that particular workload. So you also
Hello, am I audible?
okay. Sorry team, I think I had a network glitch. Am I audible now?
Yes, now you are.
Yes.
Yes, Kamlesh.
Right. So I think maybe due to the weather, there was a network glitch. Okay. Thank you. Right. Now this advice is available free of cost to us. We don't need to pay anything. It's simply a tool that we can use to identify which machine can help us out. Yes, Durga Prasad. Any query? Awesome. No problem there. Your hand was high. Great. Fine. So you have different kind of machines you can use there, right? Based on your workload requirement, you can select that different kind of machines, right? So just to test, right, that you might have a different requirement, which machine can help us out. Shubham, any query? I can see your hand is high.
Yeah, so actually I asked what's the difference between 1:2 and 1:4 in performance, and I got a response that it is memory to CPU ratio. But can you explain in more layman language what that exactly means or where we can utilize that? Any examples on that?
Okay. Any examples on that? Okay, fine. So when we talk about the fundamental power of a machine, we talk about the CPU. So if I go to buy a laptop, right, I always boast that I bought the i7 processor, right, which has 8 cores, which has 16 GB RAM or 32 GB RAM. So the more RAM you have, right, the more RAM you have, right, your application can run quickly because RAM is a primary memory that we have. And in this primary memory, we can store the application state. So I will be able to access the application at a faster pace if I have more RAM, right? So depending on, generally when we buy the laptop, we say that we require more RAM so that we can run the applications, multiple applications smoothly, right? And in the cloud, we have a different workload. Sometimes we require more compute power than the RAM. For example, right? For example, let's say you are doing a job of uh, creating a animation movie, right? You are doing a job of creating an animation movie, right? So you run the Adobe software, you create your frames. So at that point of time, you require more computation power because you need to edit the frames. You want to work with the pixels, right? And images are heavy there. So you require more computation power to uh, edit or to create your frames in that. So I require more computation power, right? Or maybe you want to run basically some of the jobs in parallel. You are running Microsoft together, you are running Apache server on your machine, you are running containers on your machine, right? So I require more computation power there. So depending on the workload, what you require more, whether you require more memory. So maybe I'm running in-memory databases, right? That store the data in memory so that you can access it the faster pace. You can use more memory power. And in case if you want to run the batch jobs, the processing task, maybe I'm running the ML task, right? To train my model, right? So I require a GPU support at that point or require more CPU support at that time to train that model. So at that time, I require more CPU power. So that's a difference. What's the computation power you require and what's the in memory space that you require there for your work. Different workloads has different requirements, and based on that, you can select the instance type. Okay.
Understood. Thank you.
Okay. I can. Sure. I can see what is a machine. And could you please explain one? Machine is simply, I can take analogy. It's my laptop that I'm utilizing right now, right? And what is the configuration of my laptop, right? How it is performing, I can see that here. So for this, I'll quickly bring my workload laptop here. You can see, right? My laptop has i7 and it's 16 GB RAM. So you can see that how much it is getting consumed. Now, along with this training job, if I want to run some processing behind the scene, but here to train my model, I require more computation power. So what is machine? It's basically a system where you can run your workloads. It's your laptop. If I talk about as an analogy, physical hardware that you are utilizing right now, your mobile phone is also a machine, has RAM as well and the CPU as well. Then same with the virtual machines. What kind of virtual machine you require in the cloud? You can select that for your workload. Okay, team. Awesome. So let's quickly see that mapping. So if I require high performance databases, right? So databases store its state in the memory to give you a faster response. So which kind of instance type can help us out in that case, which is ideal for databases? What do you feel? Databases want to store its state in the memory. So which option can help you out? I want more memory there, right? So it's memory optimized instances, right? Apart from that, I want a system for running the data warehouse application. So what data warehouse does, it stores a huge amount of data on secondary storage on your hard disk. So which machine can help us out in that case?
Storage optimization.
Right. So there, storage optimize can help me out. You require balanced amount of compute and memory and networking
General
resources.
purpose.
Right. You require high performance processors, more computing power. Right. That is compute optimized. Right. So depending on the workload, you select your instance type for your workload. Right. And which machines can help you out? Definitely you can use the get advice feature. Right. That can help you out where you don't need to get into the documentation part. You can simply get that advice right from the AWS for the same. Okay, now we have seen the options there. Now let's talk about pricing. Right, let's talk about pricing quickly. So of course, we say the cloud is pay as you go model. We can access the services on the fly and we can pay the price. But of course, I can also optimize on the cost. Right. So one option that we have, which is on demand, which is a default option available to the customers where we don't need to make any commitment, right? So it's on demand. You make a request for a resource and you'll get that resource, right? But this is a costliest option, right? This is a costliest option. Now, if you want to save a cost, now you know that you will be running a database in a cloud for a period of 1 year or for a period of 3 years. You know that you'll be running your database for a longer period of time. Make a commitment, right? Make a commitment to the cloud that I will be utilizing the database for in a cloud for the period of 1 year or for a period of 3 years. Make a commitment, and this will provide you a discount of up to 72%. Right? It will provide you discount of up to 72% over on-demand price. So if you commit to the cloud provider that I will be utilizing the resources for the period of a year or a 3, then it can provide you a discount of up to 72% over the on-demand prices. So if you have a workload that will be running for a longer period of time, go with the reserved instances. That can help you out in saving the cost. Of course, you have on demand, but this is the costliest option that we have. Apart from that, one more option that can provide you a discount of up to 90%, right? Discount of up to 90% over on-demand price, right? Discount of up to 90% over on-demand price. And that is spot instances, right? That is spot instances. Now, AWS has already created the infrastructure, right? And the infrastructure, if it is not used, it will not bring any money to the AWS. So what AWS does, it provide the additional workload that is not being used at a discount of up to 90%, right? And how it provide that with the help of bid. So you do the bid for a resource that for this particular resource, I'm ready to pay this much cost. And if no one is bidding that particular cost, you are the highest bidder. You can get the resource at that cost, right? You can get the resource at the discounted price. So even you can bid for the resources, right? So if I quickly take you to the console, you can see I have a spot request, right? And I'll just click on pricing history, right? So here you can see that the costing, the on-demand price for the machine of type C3.large is $0.1050 per hour, right? But if you bid for this instance, right, at what price you will bid? You want some reference. So you get this pricing history. So this is the on-demand price, and this instance is currently available at this particular price, 0.0319 in one of the AZ. So you can see you get up to 70% of discounts over the on-demand price with spot instances, right? So that's a beauty you have. It might go up to 90% as well. So which is the additional capacity that is not being used by the AWS, right? They provide it as a part of bidding as a spot instances, right? But this instances has a small catch. Today you say that, okay, I'm ready to pay 0.0400 dollars, which is the highest price compared to the one that we have here in the screen, right? And tomorrow someone comes, okay, will say that I'm ready to pay dollar 0.500. Then in that case, that person will win the bid and resource will be provisioned to that particular person. So spot instance comes with a catch. If you bid the higher value, you get the resources. If someone comes and bids higher than you, they will get the resources. So that is a small catch we have with spot instances, but of course we can get a discount of up to 90%. So plan how you can save the cost. Don't go with the on-demand instances. It's pay as you go model, but if you have a workload running for a longer period of time, go with reserved instances, go with spot instances, or you can go with the compute saving plan. Again, you can see it can provide you a discount of up to 66% as well, but it requires commitments. So use different plans, either compute saving plan, reserved instances, spot instances to save on cost. Commit your usage, save on cost, or bid the resources, win the bid and use the resources at a lower cost. So plan well as per your application need and save the cost. Okay, is the idea clear? Team, for those pricing options, how you can optimize the cost there? Great. Yes, Himanshu.
Yeah, so I have a question regarding this spot one. You said that there is a catch that if anyone is bidding more than the price that we have bid, so is it like if even if we allotted with that slot, still that person can be get that spot and then we will get allocated with that?
Exactly. So you will get a 2-minute notification that within 2 minutes your resources will be taken back. So in that 2 minute, you can run the automation type task to take a backup so that you are not losing anything. It's not like that someone bidded higher and it is gone. You will get that a 2-minute interval. In that case, you can take a notification. So this is suitable for a workload which is stateless, which is flexible, right? For example, I'm running a machine learning model. So this is my model, right, that I want to train. What I do, I take a small piece of data, I provide this data to the model, I train it. Again, I'll take a small piece of data, I'll provide that to the model, I'll train it. So there, this machine or the spot instances can help me out, because if the machine is taken back, no problem, my model is already trained. I saved my model. My job is done. So this is where it is useful. It's a workload which can start and stop with flexibility. For such workloads, you can use the spot instances. If you don't want that interruptions, go with reserved instances or go with compute saving plan.
So this is just a test projects, just to test our data and see how the output is. For that, it
Yeah,
would be useful. Yeah.
yeah, exactly. Okay. And how many days instance will be available? There is no guarantee, Durga Prasad. You get the instance, right? You can. It might be available to you for 2 months, 3 months. You decide how long you want to wait for that instance, right? So when I create a spot request, I can specify the interval, how long I want to wait for that resource, right? So I can specify the time limit. Just a second. So I have an option to specify. Yep, keep the request valid. I'll not apply default. So here you can see in what period you will wait for that spot instances that you can specify, right? The amount that you have bidded, it will be valid for how long you want to use that spot instance that you can mention here. And within that period, if the price is below your bidding value, you will get the resources. If it is higher, then it will not be granted to you. Okay. Awesome.
And on demand is something it can we can use if we have 100 headcount, and if we receive for a 200 headcount workload, will it can be switched to the 200 workload?
Yep, even on demand can do that because with cloud we have that scalability. No problem in that.
But costing would be different.
Exactly. If you use one machine, it is costing you 0.1030 per hour. If you use two machines, multiply by two. If you use three machines, multiply by three. As simple as that.
Okay.
Right.
And
So the amount of resources used, that much payment.
so Amazon will automatically switch it to the multiple servers rather than we assign it.
No, we need to design
Okay.
such architecture where it can scale, because if you give everything to Amazon tomorrow, it might happen 1,000 servers are there and you will say that why it is there. So somewhere some control is there in your hand as well to make sure that how much you want to scale.
Cool. Got it.
Okay? So you have an option to decide that architecture, how much you want to scale.
Got
Okay.
it.
And apart from that, two more options are available to us. One is dedicated instance and one is dedicated host, right? Two more options are there. And now this is with respect to compliance. Now, what happens in the cloud? A physical server is already created by AWS and you have a hypervisor, right? And on this hypervisor, we can run the virtual machine. So let's say this is a virtual machine which is ran by Kamlesh, customer one, and this is another virtual machine from customer two, which is, let's say, is ran by Sora. So it might happen on the same physical server, the virtual machines of different customers are running. Maybe another virtual machine is running, which is from Nilesh, right? So on the same physical server, three virtual machines of three different customer is running, right? Now your requirement is whenever your virtual machine is running on any physical server, I have a compliance requirement. There should not be a virtual machine of any other customer running on it, right? So my requirement is only what my virtual machines run on a particular physical server and of no other customer there. So in that case, you can go with dedicated instance. It makes sure that on a physical server, only virtual machines of single customer is running. Only virtual machine of single customer is running. Whether you run one machine or whether you run two machines, it will guarantee that instance runs a virtual machine for a single customer. So if you have a compliance requirement, you don't want to share your server with other customers, go with dedicated instance. That can help you out, but it comes at a higher cost. So that is also an option to you. If you have a compliance requirement that on the physical server, only your machines, your virtual machines can run and of no other customer. And apart from that, if you need to bind the server-based licenses, right? If you need to bind the server-based licenses, right? You have some server-based licenses that you want to bind to the underlying hardware with the cloud provider, then you can go with a dedicated host. This is the most expensive option in terms of EC2, right? This is the most expensive options you have. So if you want to reserve a server, you want to bind a license, go with a dedicated host. So these are options available to you based on your requirement. You can select the same. Okay, is the idea clear? So how you can save the cost and how you can meet the compliance requirements as well if you have any there. Yes, Himanshu.
Yeah, so you mentioned that dedicated instance. So is there any drawback if we share the same with any other server?
There is no drawback. Virtual machines are secured, but if you have that compliance requirements, right? Maybe you are running application, right? Some compliance requirement is there. Because of that, you can go with that particular option. Because by default, in the cloud, we have a shared tenancy. On the same physical server, virtual machines of different customers are running.
Okay,
Okay.
thank you.
Sure. Now let's talk about auto scaling. As we were talking about, I even got the option as well. Probably, I think it was from Nilesh or Himanshu. I can't recall that. If I use 100 EC2 instances on demand, if I want to scale to 200, can we? We can, right? But scaling need to be done by us, right? And there, auto scaling can help me out, right? Auto scaling can help me out, right? So if we take an example of again a coffee shop, right now I have two customers in a coffee shop. One barista is sufficient to serve the two customers. As the customer increases, I need to increase the number of baristas as well so that the customer can get the coffee uh, without much wait there, right? So what we can do, we can increase the number of baristas to serve the customers, right? Moving out, what this EC2 auto scaling is doing, it is doing the same thing for me. It is scaling my EC2 machines based on traffic, right? So on Sunday, I have less traffic. So one EC2 machine is sufficient for me to handle the workload. On Monday, I have little bit more traffic. So I require two EC2 machines. On Tuesday, I have more traffic. I require three EC2 machines. On Wednesday, I have the highest traffic. I require four EC2 machines to serve the customers. And gradually the traffic decreases. Thursday, three EC2 machines. Friday 2 and Saturday 1. So you can see entire week I have different requirement of a EC2 machine, right? And I don't need to go and sit there every day. I need to change it. With the help of auto scaling, I can configure uh, the threshold, right? I can configure the threshold for the utilization of a machine. And based on that, the scaling will automatically happen, right? So this EC2 auto scaling will make sure it scale my resources based on demand. So this EC2 auto scaling, what I do, I configure what is the minimum number of machines that should be running every day and what is the maximum number of machine that can run over a period of a time. So I specify minimum number of machines. I specify maximum number of machines that can be running for me with an auto scaling. And how many machine will run? It depends on how many clients you have who is accessing your services. So if you have two clients, one machine is sufficient. If you have four clients, two machines are sufficient. If you have six clients, three machines will be sufficient. If you have eight clients, four machines will be sufficient, right? So based on the traffic that your machine receives, you can decide how many EC2 machines you need to have to serve your customers, right? The scaling happens automatically, but it will scale up to a number, the maximum number that you set here, right? So this is what this auto scaling does for you. Automatically increase the EC2 machines, automatically decrease the EC2 machine based on, rather than customers, I'll say the clients who is accessing your application. Now, how you identify that? How many clients are there? What is the load on the CPU? So for your machines, metrics is available, right? For your machine, the metrics is available. What is metrics? I'll quickly bring here, which is right now you can see the utilization of my CPU, which is close to 80%, right? So if I open more applications, more CPU load will be there, and there is more clients who are sending a request, more CPU load will be there on my machine, right? So I can decide that how many requests is coming to my machine based on the CPU utilization, based on the memory utilization, based on the network traffic. So whichever metrics that you want to utilize to measure the traffic, you can use that metrics. So if let's say I have currently one machine which is running, right now one machine is serving a client, and what happens? My CPU utilization is more than 70%, right? My CPU utilization is more than 70%. So I will scale out the resources. So rather than one, I'm running two machines. So what will happen once two machine comes into serving the customers? This CPU load will decrease maybe up to 38% now across two machines. Again, after some time, more customers come, the CPU load across the two machines reaches, let's say 65%, right? Then again, I'll add one more machine. So I'll check the metrics of my machine. What is the load on the CPU or what is the load on the memory? And based on that, I will decide whether to add the machine or whether to remove the machine, right? So based on that, we can decide when to scale up. So with auto scaling group, we have a scaling policy. And in this scaling policy, I'll simply write a rule. If CPU is more than 70%, add one machine. And if CPU is less than 30%, remove one machine. So I'll configure this particular scaling rule, and based on the utilization of CPU, aggregate utilization, it decides whether to add the machine or whether to remove the machine. So it can scale your resources based on the metrics of your machine, based on the utilizations of your machine. So we can scale out or we can scale in, which is reduce the number of machines based on the traffic that you have on your machines. Is the idea clear? See what auto scaling does for us. Add machines, remove machines based on the traffic. Yes, Prem Kumar.
Then while doing this auto scaling and scaling in or scaling out, how this data redundancy is getting managed here?
How?
How the data redundancy will get managed. Suppose I'm running one application over machine one. Today I need only one machine, but maybe in tomorrow morning I need two machines, and my customers are coming, and maybe the same customers may come frequency in time multiple times. Maybe in one time one machine get catch by that customer, another time machine two will get by that customer. So how this the data will be that integrity will be happen? How whatever I have.
Exactly. So one thing we can do is we can store a data at a central store. I have a database. Now both the machines can access the data from the database. Not a problem in that case, if you want to maintain that particular data. And in case if you want to make sure the customer should be able to access the data which is locally on the machine, in that case you can enable the feature of stickiness that also you get. So every time the same customer will be sent to the same machine. So you have this option how you want to handle, whether you want to maintain stickiness where customer will jump to the same machine every time, or you store that in the central data store such as your RDS or maybe S3 as a storage service that you can use there.
Okay, so suppose we use this stickiness, and then each time this machine should know, right, which customer is coming. So same customer, you have to identify, right?
So
then
that stickiness, we don't have to worry about that. That stickiness will share the token, right?
Yeah.
In the request, and with the help of that, they will be able to jump to that particular machine. So that is automatically managed for you.
Okay.
Okay.
Then for suppose number of customers have been stick to the machine one, then this token will generate for each customer. Then how the latency will be here? The performance may be increased for one machine and maybe less for another machine.
So I'll come on that. Just give me 2 minutes because I just talk about auto scaling. Here the customers have freedom to select machine to which they want to talk to, but actually it's not the direct communication between the customer and the machine. It's a load balancer that comes in between, right? So it's a load balancer that comes in between, and this load balancer distributes the traffic across the machine. So customer talks to the load balancer, and load balancer, based on which machine has the less load, it will send the request to that respective machine. Right? So I'll talk about that in few minutes, Steve.
Okay.
Okay. Yeah. So we talked about auto scaling. Okay, I think Yusuf, any query?
Sorry, Kamlesh. Actually, so database will be for every machines you said, like, am I correct?
Exactly.
So in the load balancing NLB, I think data would be should be the on the every machine. Like suppose if there is one common database and we are getting slowly data, means database responding slowly, then what is use of many machines?
So with database, we also have a RDS proxy that can help us out. So what happens with database? You manage a RDS connection, right? So if every machine will keep a connection open, database will not be able to handle it. So what we do in that case, we make a use of RDS proxy, right? So all these fundamentals comes in the associate level courses, right? So rather than talking directly to the database, what we do, we talk to a RDS proxy, right? And this RDS proxy will make sure that to the database, only that many connections are opened as much possible. And if there is more than that, this proxy will manage that for you, right? So it again, if we go dive deep right now in the services, right? Of course, we can discuss it, but that's a part of the associate level courses there. In exam, you don't have that depth. You have only uh, cautions on the familiarity of the services, what feature that services provides, what that service does for you. This is where you will get the questions there. Okay,
Okay,
Yusuf?
okay, fine. Okay,
Great.
fine. Thank you, Kamlesh.
I can see Aktachaya. Any query?
Yeah, I have a query. Like we are using minimum instances and maximum instances, right? Uh, re- for
Auto
the
scaling.
traffic. Yeah. Like how we will pay for this instance?
So the number of instances you utilize, based on that you get the bill, because AWS tells you that uh, so let's say you are running this machine for 2 hours, this machine for 1 hour, this machine for 30 minutes, right? So in all, how much time you utilize, because this is same kind of machines you have. So 2 plus 1, 3, 3. So it's 3 hour 30 minutes for which you pay.
Okay,
That's it. Simple.
so we can have maximum n number of instances, and only for what we use, we are going to pay for that.
Exactly.
Okay, thank you.
Okay.
Yeah.
Great. So it's 8:23, right? We had the discussion on that auto scaling, which scaled out the time. So let's have a short break, right? Once we come back from this particular short break, we'll carry out a discussion with load balancer. Okay, so I'll quickly go back to the timer and let's have a break. Once we come back from a break, we'll carry out a discussion again. Okay, enjoy the break, team. Okay, team, I am back. And if you're back in session, to drop your update in chat. So team, are you back?
Yes.
Yes, sir.
Right.
Yes.
So if you're back, just drop a update in the chat. Yes, back, anything you can type. I can see the message started appearing. Great. And let's move ahead. Let's talk about our next content that we have, right? Just give me 1 second to bring the screen. And I'll just switch my network team. There is problem with my network. Just give me 1 second to switch the network. Okay, fine. So begin. Let's talk about the load balancing as another feature that we have. So what this load balancing does, it distributes the traffic across the machines. Now, because I can increase the number of machines, I can decrease the number of machine. So to which machine a client need to connect, how a client will come to know that, right? So with auto scaling, we have seen the feature. Maybe right now I have one machine with which I'm serving the clients, but I can have increase in the number of machines. I can have scale out, which can increase the number of machines, or I can decrease the number of machines based on the traffic. So how the client will come to know that to which machine I can connect, what are the IP of those machines. So I don't want to give this responsibility to the client. So what we can do, we can add a layer of load balancer, right? So client will send a request to the load balancer, and load balancer will start distributing the traffic. It will make sure the traffic goes to machine one. And it's not only machine one, traffic also goes to machine two and machine three. So this will distribute the traffic across the machines, load balancer, right? So just to make sure client do not have to worry about which machines are running, client just need to send the request. Load balancer will distribute the request to the machines. Okay, so let's understand the load balancing. Right now, why we require this load balancing? Again, we have an analogy of a coffee shop. So we can see that this barista that we have on the left side of our screen, this is overloaded. It is serving 3 customers. And this barista is enjoying only serving 1 customer. So we don't want such kind of things to be there in the IT, that one of the machine is overloaded, one of the machine is not overloaded. So we want a balance of workload across the machines. And this is what load balancer does for us, right? This is what load balancer does for me. Automatically distribute the traffic across multiple machines. And for the client, it provides a single point of contact. So client don't need to worry about machines, how many machines are running. It just need to send a request on the single point, whether there is 2 machines or whether it is 4 machines. This load balancer will distribute the traffic there, right? This load balancer will distribute the traffic there. So let's quickly see that small demo, right? So I'll quickly take you to the console. And in the console, if I go on EC2, during the break, what I did, I just launched one more machine. So here you can see this is a machine that I have launched, right? And machine one, machine two, 2 machines are there. So I'll just do HTTP, paste the IP. You can see one machine is running the green color page. Another machine is running the blue color page. So just to differentiate 2 different machines, both are running the different color pages so that we can identify, and also we can read the IP address, which is different here, right? Here it is 18233, here it is 2082. So 2 different machines are serving the web pages to the customer, and I don't want customer to worry about which machine, which IP address is there. So the load balancer can help me out here in this case. So what I can do, I can create a load balancer. So I'll quickly go back to load balancer, right? And I'll say create a load balancer, right? and I want to handle a traffic for a web server, which is HTTP traffic. So I'll go with application load balancer. I'll say create a load balancer. I'll give a name to this load balancer. I'll say this is my application load balancer. I want it to be internet facing to serve the clients, and subnets in which my machine is running. I'll select that security group that will allow a traffic on port 80, and a target group. What is this target group? This target group is a set of machines that will receive the load. So if I open this target group, I just pre-configured it. So let me just create this load balancer. By the time this gets created, you can see the target group, which is a set of machines that you want to use to serve the customer. So if I click on this target group, you'll see I have two machines, right? I have two machines, my machine 01, my machine 02. Both are registered with the target group, right? Both of them are registered with the target group. And this is my load balancer that is getting provisioned. And so once my load balancer is provisioned, I don't need to send the request separately to each machine. I will send a request to load balancer, and load balancer will send the request to the machines behind the scene. So let me quickly close another tabs not required. Fine. So let's see. If load balancer is provisioned, and I'll copy the DNS name of a load balancer. Okay. So let me open this in the new tab. Let's press enter. And once my targets are healthy, we'll be able to see this as well. Fine. So it will take a minute or two for us. Right. So let's see if our load balancer is healthy and available. So it is still provisioning. So let's wait for it. Let it provision, and then we'll see that with the common endpoint, I can reach both the machines, a blue machine as well as green machine. So with the help of load balancer, I can distribute a traffic across the machine. Client don't need to worry about where to send the traffic. Client will send the traffic to the load balancer, and load balancer will distribute the traffic across these machines, which is a part of a target group, right? It is a part of a target group. Okay, is the idea of load balancing clear? Yes, team, what load balancing does, is that idea clear?
Yeah, it's clear. Can I ask, do we have any backup load balancer where if the both servers are down, so that we can send out to the alternative server?
So load balancer is there to distribute the traffic, right? Who will make sure if a server is healthy or not? It's auto scaling group. So if any of the server fails, this auto scaling group will replace that server with the new machine. So we don't need to worry about, because that is a responsibility of auto scaling group to add machines or to remove machines if they are not running. This is what auto scaling group does for us.
Okay, got it.
Right. So scaling.
And
sure.
Sorry, Kamlesh. And why we need to create load balancing from our side? Because it should be automatically load balancing from the AWS side, na?
Yeah, but to which machines we need to see? We are designing an application, right? We decide which machines we use for which application. I may be running 1,000 applications, right?
I'm asking because actually it is increasing machines at per users or load, right? So it needs to be create create a load balancing automatically, na? That's why I'm asking.
No, it's a different responsibilities, right? It's a different responsibility to increase and decrease the machine that we do on the usage of CPU and the memory of the machines. So this is what auto scaling group checks for. Okay, CPU is more than 70% for a particular machine. I need to add one machine, right? And if CPU is falling less than 30%, remove the machine. So this is a job that auto scaling group does. This is what is a responsibility. In cloud, every service perform a specific task. So this is
You
auto
mean
scaling is
okay.
doing.
Okay. So
Okay.
you mean if we are not creating manually load balancing, then it will not increase the CPU as per requirement, right?
It will increase automatically because what auto scaling group is doing, it is monitoring all these machines. What is the utilization of these machines? If it is, let's say if the CPU utilization is more than 70% across both the machines, that means I will need one more machine. This is what auto scaling group is monitoring, these machines. And it is not
Okay.
checking how many
Okay.
customers
So
are there.
okay. So what will be if we are not creating a load balancing from our sides? Then what will be?
Then you
Then
decide.
it will not
So
it will not balance the load.
no, of course, because for if load balancing is not there, you have a IP address. Let's say this machine is 1.2.3.4. This is 2.3.4.5. So you give IP address to the customers. Now customer will say that, okay, I want to send a traffic to this machine. So every customer is sending a traffic to this machine, right?
Okay. That means multiple machines will not work for us, no?
Exactly,
Right?
right? Exactly,
Oh,
right? We don't want that favorite machine to be there across the customers. We don't want to give
mhm.
idea to the customer how many machines are there. You send a request to load balancer will send the request to the machines for you. Okay,
Okay. Got it.
sure. Yes, Zafar, I can see your hand
Yeah,
is up.
so
Please go
I
ahead.
have a scenario in which the application is sensitive to IP address. So it has got sensors, and the sensors are connected to a particular IP address in the legacy system.
Hmm.
So now, if they move to cloud,
Hmm.
will that is there a way we could have the IP address at the load balancer level so
Yes,
that
you can have it. That is also possible. In that case, if you want to have a load balancer with a fixed IP, that is what is a requirement. In that case, you can make a use of network load balancer. That's another network load balancer that is there that you can make use of. It provides you a static IP where your sensors can send the requests.
oh, I see. I
Okay.
see. So this network load balancer may get connected to 10 different machines, and the IP address of those machines will not be relevant for this scenario.
Exactly.
Oh, great, great. Okay,
Fine. And now
thank
you
you.
can see the URL that I was talking about. I'll share that in the chat as well. Right. And you can see this is blue page. If I refresh this particular page, it's green. Again, if I refresh this particular page, it's blue. So what this load balancer is doing, it is sending a traffic to both the machines, right? Distributing a load so that none of the machines getting overloaded then. Okay, I hope the idea is clear for the load balancer.
Yep, pretty clear.
Awesome, great.
What was the need of network? You told network load balancer.
Yes. Yes,
Told
Ajay,
another,
can you?
yeah, you told another load balancer that is a network load balancer. And how it is different from the other one?
See, with the applications, right, at which layer of OSI you're utilizing your application, you can select your load balancers, right? So that again, a discussion we go into the associate levels, right? So if you want to run IPS, right, or IDS kind of systems internally, you can go with gateway load balancers. If you want to handle the UDP traffic or TCP traffic, right, you just want to send the data there. You want high performance, go with network load balancer. You want to handle the traffic at HTTP, HTTPS, go with application load balancer. So what is your requirement? Based on that, you select your load balancer there, Ajay.
Yeah.
Okay.
Okay.
Sure. So let's quickly see the examples, right, that we have, which is the responsibility of auto scaling and which is the responsibility of elastic load balancer, right? 6 options are there. So you can drop in a chat what is the responsibility of ASG. So maybe I'll give you a hint. One is definitely there for ASG. So what other things are done by ASG that you can mention? And same with elastic load balancer, you can write ELB and you can write the numbers. So what do you feel? Write all the options, what you feel, which options is managed by ASG, auto scaling. So I can see two answers in the chat. ASG 125, remove instances, add EC2 instances, and automatically adjust the number of EC2 instances. I got the answer in the chat from Siddhi and from the Rohit. That's right. So that is the responsibility of ASG, and whatever remains is the responsibility of load balancer, right? Distributed traffic across the instances, ensure none of the instances overloaded, and it provides a single point of contact for a client, right? So I hope the idea is clear. The responsibility those two services manages, load balancer and auto scaling group. Is it clear?
Hi, Kamlesh, Samira here.
Yes, Kamlesh.
If it's possible, could you please give a brief on this access case? I lost my network and I missed this concept.
Sorry, brief on which concepts?
This access keys and secret key.
Access key and secret key. We haven't covered it yet,
Oh, okay.
right? We only talked about load balancer and auto scaling group till this point.
Okay, okay. I just lost my internet connection, so I was thinking this topic was covered. Okay, thank you.
So
I'll go
let's
through the
talk.
load balance.
Sure, that we have covered. Let's talk about messaging services. Now we have a microservices, right? And in case if you want to give ability or services to send notifications, right? You want to provide ability to send notification to the services, right? Or let's say you have a component one, you have a component two, both work at their own speed. And you want to make sure both the components can talk to each other because speed is different. And I just need to make sure both components can work independently. Then in that case, I can also use buffer in between, right? So that both of them can talk to each other at their own speed, right? So I'll keep you make a use of buffer where they can send the messages, where they can store their messages, and they can communicate with each other even at the different speeds at which they will. So if you want to overcome these situations, we want to give ability to send notifications, or we want to have communication across the services that work at different speed, right? So this is where this app messaging service can help us out. One is SNS that can help you out in giving the notification ability. What happens in SNS? This is based on PubSub model simply, right? So in SNS, we create a topic. Publishers can publish the message. You might have multiple publishers as well. And all the subscriber who subscribe to this particular topic will receive the update. So anytime the message is published, all subscriber will receive that update, right? All subscriber will receive that update. So that's a benefit that we get with the messaging service SNS, right? We can send the notification with SNS, right? So that's one service we have. And another service that we have, right? All subscribers that we have, we can add it to the topic and all subscriber can receive the notifications as well. Fine. And let's quickly see the small demo. So anyone want to share the email address? Any one person, two persons can share their email. Quickly, we can see the small demo, how you can get the notifications. From the services, right? So I got from Tarun. I'll take the email address of a Tarun quickly just to show the demo of SNS. I'll get into SNS service, right? I received a lot of the emails. I'll just use one, right, to save the time, but we can see the notification in action there, right? So I'll go to the SNS. I have few topics, right? I'll get into my topic, right? And I'll just delete this one that I have used before, right? You can see my email address is already subscribed. I'll create a subscription for Tarun. Okay. And Tarun, you will receive an email and you need to confirm the subscription. Okay, Tarun. So just do that favor. Please confirm the subscription so that you can receive the update in the email. And by the time Tarun does that, I'll jump to a service S3, which is a storage service, and I'll configure S3 to send a notification, right? As I said, SNS provides the ability to send a notification, right? So let's, by the time I get the confirmation from the Tarun, right now I'm in the US East 1 region, and I'll use the bucket, this one, 0, 1, 2, 3, 4, 1, 2, 3. That's a bucket that I'm utilizing there, right? And I'll give the permission to this bucket. To send the notification. So at any point of time, if any object is created in this particular bucket, send the notification to my topic. Fine. I configured my S3 service to send the notification, and let's see if Tarun confirmed the subscription. So Tarun, have you confirmed the subscription? I cannot see here. Or what I can simply do here, I can. So I think probably it's different. Not the problem if it is not confirmed. I have already my email subscribed there. Fine. So I'll directly upload an image, right? Rather than again configuring it. Okay. So I'll upload an image in S3. So I'll go to objects. I'll say upload an image. Let's add a file to this. And let's add a file from the downloads. I'll add a file which is day1.pdf. That's a file that I'll just add it here. So I'll say open and upload the file day1.pdf into a bucket, right? It's a 3 MB file that got uploaded with the name day1.pdf. And as soon as this file get uploaded into S3, I'll receive an email as well in my account if I get there in my account, and we'll be able to see the notification, right? And here I'll copy this record of notification. The font is little bit small. I'll copy this partly and I'll just use my Notepad++. And here you can see an object with the name day1.pdf of size around 3 MB is uploaded. In which bucket? In a bucket 0, 1, 2, 3, 4, 1. That's a bucket where that object got uploaded. So I got a notification there, right? For object that is uploaded, right? Tarun, I just only added one topic, one email address to the topic, not for all the members, right? I just added the first email address that I have received, which is ikkatarun@gmail.com. I think this was not confirmed. I added only one subscription. Of course, I can have multiple just to save the time. I added 2 subscriptions there. So that is not there. So first email address that I received in the chat, that is added. Right. So I haven't added all the email IDs. Of course, I can do, but that will take the time. I just wanted to show you. Okay, this is the email which is there. So what I can do, I can create one more subscription. Let's say email, let's paste. Now you can confirm that you might have received the email for subscription. Right. So once you confirm, you'll be able to see here confirmed as well there. Fine. So you can confirm, we'll confirm it later on whether you subscribe to it or not. But I hope the idea of SNS is clear. If you want your services ability, right, to send the notification, use SNS as a service. Right now I have shown you. Okay. Swapnil confirmed. You can see here, if I refresh now, we can see Swapnil confirmed. Sorry, Tarun confirmed. Swalika Tarun confirmed the subscription. And again, if I upload some more file, let's do that once more quickly. So I'll say upload a file, add a file, and let's quickly add a file. Let's add this file, trivia underscore template.csv. Let's open, let's upload the file. And again, as soon as someone adds a file into S3 bucket, they will receive the email. So Tarun, have you received the email now? Can you check? Another email with the information for the same. So if I go back here, you will see one more notification to me. And this time it's trivia template.csv file that got uploaded. And I have received the notification as well as Tarun received the notification. You can see the file uploaded, trivia underscore template.csv. So this is what SNS does. Gives your application ability to send notifications. So sometime if your auto scaling group is scaling up, scaling down your machines, your web server is not working, you want to receive the updates. SNS is a service that can give ability there, right? That the following file has been uploaded. Okay, I can see the caution from the Zafar. Why we are not seeing the actual file? Because file, the data we want to store in S3, I don't want to distribute data to the other customer. This is just a notification. For example, we have a Zomato, we have Swiggy, right? We only get the offers, right? If we buy the food, then we can be able to apply the orders. So if you want to do the processing, you should get a notification that the file is there with the given name. So SNS is a notification service that something happened, right? You got a notification, then whatever you want to do, an automatic action or a manual action, that you can decide, suffer in that case. Okay, fine. I can see the Shubham also with the query. Shubham?
Yes, sir. So currently what I can see is there's a very unformatted way of displaying the message, like probably an XML. So is there any way to make it more formatted, like a file is being uploaded with the file name or something like that?
So standard format is this, which is directly given from S3. If you don't need this, if you want to send a custom messages, of course you can do that, but it will cost you a little bit. So what we can do in that case, you can use S3 sending a notification to SNS. And rather than SNS sending a notification to the customer, you send a detail to the Lambda function, and Lambda function will again send the notification with the proper formatted message if you require. So you need to do the processing in case if you want to send a custom message in between.
Okay.
Okay.
All right.
So we can add that particular layer. There is no problem in that. Right. Moving out, another service that we have, which is SQS, right? And what this SQS does, this act as a buffer between the sender and the receiver. Why we need this? So you can see it send, store, and receive messages between the software components. Why we need this? Because services work at different speed, right? Services work at different speed. And just to make sure the messages are not lost, I can buffer the data in between, right? I can buffer the data in between. So here, if I again take an example of a coffee shop, you place an order. So maybe 10 customers already placed the order, but the barista can make a coffee at one coffee, let's say 5 minutes it takes for a barista to prepare. Already 10 customer placed the order. So what is happening? Order is placed at a faster pace, right? Order placing is one order per minute, right? One order per minute. But when you make a coffee, it takes 5 minutes. So definitely we can see we receive more orders and coffee is taking time to get ready. So what we can do in this particular case, right? This will happen in IT solutions as well. The services work at different speed. So what we do basically in the coffee, we have this hook section where we add the bill, right? And barista will take one bill in a sequence, will make a coffee, will deliver it. Takes another bill, will make a coffee and will give to the customer. So what this is area, this is buffer where we place the order that is given by the customers. And that is what SQS does in the IT services as well. It's a buffer. So as soon as the customer places the order, it goes into that hook section, right? And as soon as the barista is ready to make mixed coffee, it can take a order and it can make that coffee ready. So that is what SQS does. It acts as a buffer, right? It acts as a buffer. So two services work at different speed. We don't want message to lost. We can use SQS there. Okay. And I can see, can you share the real scenario example of this SNS, Nayan? For example, Nayan, let's say my web server is down. Who will tell me? I don't want customer to give me a call that my web server is down. I want to get notification, right? So I can make a use of SNS in that case. If my machine stops working, I can get the message directly that the web server is down. So I don't need to wait for a customer to give me call your website is down. Okay, Nayan? Is the idea clear?
Yeah.
Awesome. Moving out further, let's talk about serverless computing. Now, till this point, we always said that we have a server that we need to run and we need to serve the customers. But nowadays in the cloud, you can run your computation task without provisioning server, right? You can run your computation task without provisioning servers, right? How this happens? Now we have an idea that we will provision the server, will write the code for the tasks that need to be done, and that code will be executed, right? That's what we have. Now the scenario is changing. You just provide a code that you want to get executed. That's it. AWS will create a server down the line. Code will be loaded in that. Code will be executed. And then again, that machine will be taken out. So you don't need to run server continuously for your code to get executed. Whenever you need, whenever the event happens, the small VM will be added, the code will be loaded, that code will be executed, and then that machine will be again taken away. So now we don't need server to run 24/7. We just provide the code for the task that we want to run, and whenever the event happens, code will run in that. So that's a beauty that you get with the serverless computing, and you get this beauty with the help of Lambda. Run code without provisioning or managing the server, right? That's a beauty that you get with the Lambda, and you can trigger this Lambda function manually, or you can make AWS services to trigger this Lambda function as well without any issue, right? So let's quickly see the small example of Lambda. I'll quickly go back to the console, right? I'll go to the Lambda. That's the last demo that we have in this module, right? So I'll go to the Lambda and I'll quickly create a Lambda function. Let's create a Lambda function. I'll give a name. This is my Lambda function. Which runtime you require, because you are providing a code, what runtime you require. I just want to use Python as my runtime, right? So I select my runtime. I select my function name. My function is ready for me, right? And I can write my computation logic in this function, right? So let this get created. It is ready for me, and I get the sample code here in the function, right? So here you can see the sample code for this particular function that's getting loaded. And in this function, I'll simply write a message. So if you call this function, so I'll say hello from the Lambda to the Tech Mahindra team, TechM team, right? So I have this particular message as a part of my computation. So when you call this function, it will return that respective message to you. I'll get into configuration. I'll get into function URL. I'll create a URL for this particular function so that you can trigger this function. So I'll copy the URL, right? You can call this URL in your laptop. If it is allowing, great. If it is not, I'll run the same in my machine in the browser, the same URL. And as soon as I run this particular URL, you can see I got the message back, hello from a Lambda to Tech Mahindra team. So you can see my code is getting executed, no server is there, and yet whenever it is required, a VM is executing my code. So we can run now the computation task without provisioning the server with the help of Lambda, right? With the help of Lambda. So it's great. You just upload your code, right? What you want to run and on which events you want your Lambda to trigger. Right now, I just provided the URL. You can also trigger this Lambda with other AWS services. And whenever the event comes, the code will be executed for you. And if code is executed, you pay the cost. Else you don't have to pay the cost for Lambda. But Lambda comes with a limitation. So Lambda can run maximum for 15 minutes. And the memory it can consume when it is running is 10 GB. So this is one limitation that we need to keep in mind with Lambda, but rest, it can handle everything for you. Whenever the event comes, it will run your code for you. Okay. Yes, Shubham.
So sir, I see two parameters in the Lambda function. If you can explain about that.
Two parameters
as in when you were creating a Lambda function, there were two parameters in close brackets of that function.
Name of a function and runtime.
Yes, I believe.
Yep. So what name you want
No,
to give to it?
Not here, not here. When you when you wrote down that Python query.
When I created the function URL.
No, not here. When you were writing down hello from the Tech Mahindra team, that thing.
Okay,
that code.
So you want to ask me about the code?
Yeah, there were two parameters that was asked in the Lambda function.
Yeah, this one.
One was event and then second was context.
Exactly.
Yeah.
So event is basically who has triggered this Lambda function, right? So if I want to get that information, that is there is a part of an event object, and Lambda is serverless. It write its logs. So where it will write that log, that information is there in the context object.
Okay.
That's why it is there.
Okay.
Okay.
So context is used to just debug it.
Yeah, it's info about the environment where the Lambda will write the logs, how much memory it has used. That is there.
Okay, understood.
Yes, Deepak?
Yeah, hi, Kamlesh. So in runtime environment, I see different languages that we can select. And so I see mostly people use Python. So is there any advantage that we get using Python over other runtime environments?
So Python is widely used because one, it is easy to adapt for automation, right? We can simply see the source code and it can directly run. So we don't need to worry about compiling a code and doing all those stuff. So Python is little quicker to run and it is easier to adopt for automation. So that's the reason they use. But of course, it's not limited to Python. Even you can use other languages as well.
Okay, got it. Thanks.
Okay. And last thing that we have is containers, right? Now you can even run the containers on AWS, right? And to run the containers, you can use ECS or EKS as a service. So ECS is Elastic Container Service that is available if you want to run the container workload. And this is AWS proprietary service available to you, right? So if you are okay to lock yourself to AWS, you are okay with the AWS as a cloud provider, you can go with Amazon ECS. Now this has integration with a lot of AWS services. It is native product of AWS. So you can use ECS and it's easy to run your containers with ECS. It's very, very easy to run, right, with ECS. But if you don't want to tie yourself to the cloud provider, then you can go with EKS, Elastic Kubernetes Service. Now, Kubernetes is again an open source platform for running the containerized workload. You can run the workload with Kubernetes in your on-premise data center, as well as you can run the Kubernetes workload in the AWS cloud or even with other cloud providers. It's an open source platform. But remember, to run your workload with EKS, you need to put more effort because EKS has its own learning curve. So you can run workload with EKS, but it requires more effort. So you decide if you're okay with AWS, go with ECS, the easiest way to run your container workload, or use open source platform, which is EKS.
EKS or
Kubernetes.
EKS or Elasticsearch Kibana is same thing or different?
What? Ajay?
Elasticsearch Kibana is, some people ask.
That's a different service.
Okay.
That is for
Because
searching.
sometimes interviews they ask, okay, do you know Elasticsearch Kibana ELJK stack with EKS something people?
So Kibana and open source is again a different services that we use in search and analytics. That's a different thing. Kubernetes is for running the containerized workload.
Okay.
That's a different one. Okay. And if you want to run the containers without managing the infrastructure, the way you ran the Lambda functions without the servers, you can run the container images, your Docker images, without the underlying machine, right? Because the machine will be provided by the AWS in the format of Fargate. So that's a beauty you have. You can run the containers without managing the infrastructure with the help of Fargate. So run your containers without managing the servers, right? Run your container without managing the servers. That's the beauty that you get with the front. And that completes our computation model that we have seen. I hope the idea is clear. What computation services we have? We have Lambda, we have Fargate to run the container workloads on ECS or EKS, and we have seen EC2. So I hope the idea is clear till this point, team. Okay, so my colleague is dropping the questions as well from the exam point of view in the chat. So you can refer
Kamlesh,
it. Yes, Zafar?
I just thought that you went a little quickly on the containers, but that may be just me. I just thought that you went a little quicker on containers.
Zafar, I'm sure you're feeling that because I've gone with the demo with other services. I can go with the containers as well. But as I mentioned, in CPE, you only have the talk about the services, what their services does, right? So that would be the reason. If you want containers to be there as a part of a demo, give me some time after 11 post session. I can show you the demo for the containers as well, right? Because if I go for a demo of each service, that will not be able to complete the outline, because in the outline CPE is first stepping stone. What service does for you, that is there basically.
Got it. No, I don't think we'll need the demo. Thank you, Kamlesh.
Yeah, that's not required from exam point of view. They won't ask you how to configure Fargate or how to configure Lambda, right?
Right.
Awesome. So let's move ahead. So a customer want to run an EC2 instance for a batch processing workload, right? So batch processing means I want to run multiple jobs in parallel. So what I require. Yes, Tulika? Any query?
No query as such. Just wanted to check the first module which you have covered so far. Do we have any documentation which we can refer for the exam purpose?
As I mentioned at the end, I'll share the link with you where you can get the documentation as well as the reference material to refer it. And also in between, I think my colleague is adding the links in the chat that you can collect, or maybe at the end of the session, I'll share the common links.
Okay, yeah. Thank you.
Okay.
Yeah.
Right. So I'll quickly go through the knowledge check for batch processing. That means I require more compute power to save the time. So more compute power means I require compute optimized instances, right? In that case, what are the contract length for the reserved instances? So you need to make a commitment to AWS that will use the resource for a longer period of time, right? And the period that we can select, right? Which is either 1 year or 3 year. I can see the answer appearing in the chat. Thank you for that answers. It's 1 and 3. Those two options are there that we can select as the commitment period with AWS. Fine. A customer has a workload that will run for a total of 6 months and it can withstand with interruption. So it's okay to have an interruption if workload is stopped and it can run for a period of 6 months. So which is the most cost efficient option in terms of EC2 purchasing, right? Which is the most cost efficient option, right? It is saying that it will handle the interruption and we know that spot instances provide us the highest discount. So it's option T that provides you the discount of 90%. And they say that I don't want a workload to be running continuously. Interruptions is okay. I can handle the interruption. So spot instances is one that we can utilize in that case. I can see many members mentioning D. Some has mentioned B as well. So of course, B will help me out. I can run the workload on B as well. But thing is cost efficient. So these keywords are important from exam point of view, what they say, right? Based on that, you select that which is the option that will help you out. Okay. Fine. And a customer want to give messages for a specific topics to which they have subscribed. So which service they should use. So to have us notifications, which service we can use, that is SNS, right? So that's how they give you the questions in exam. It's not that deep. It is only with respect to the services, right? And that completes our module of compute. Okay. And I'll quickly bring my next module. Global infrastructure of AWS. Okay, so how the global infra of AWS is organized, right? And how you can reach globally to the customers with AWS, right? So see the global infrastructure of AWS. We'll talk about availability zone. We'll talk about edge locations, right? And different methods for provisioning the AWS services that we'll see in this particular module. So let's start. We'll talk about global infra, how you can get closer to your customer. We'll talk about AWS outputs and how you can interact with AWS services. That's the 4 topics that we have. If I quickly get here, right? So you can see I have a cafe there and there is a parade which is arranged, and due to which you can see all the roads which is there leading to my coffee shop, they are blocked, right? So this is from where the route of parade is, and all these are blocked. What will happen here in this particular case? Customers will not be able to reach my coffee shop. So what I can do, there might be a scenario, right, when the services are down or services are not reachable. So I need to make sure that I create a global footprint. If customers cannot reach one outlet of a cafe, they can reach another outlet of a cafe, right? They can reach another outlet of a cafe. So in the same way, we should design the IT solutions, and AWS allows you to design your solutions and that you can make available to the customers across the globes, right? So in this global infrastructure, let's first explore the regions, right? In the global infrastructure, and then we'll talk about AZs. So AWS already has created its infrastructure. So we have seen the page. If I go back here, if I type global infra on AWS, you'll see it has already 36 regions across the globe, right? And which regions you will select. So 36 regions are there, which one you will select. So these factors can help you out quickly. So first factor that is there, which is compliance and data requirement, right? Compliance and legal requirements that you have. Let's say you are storing the data for the Indian customers, right? So you create a project for the Indian government, and Indian government tells you that you want to store the PAN and Aadhaar data of Indian customers, right? You need to manage the PAN and Aadhaar data of Indian customers. What is the first limitation that you will get from the Indian government? Make sure the data of Indian customers remain within the Indian region. You should not be storing this data anywhere. So the first factor which is critical is the compliance and the residency requirement for the data that you get from the customers, and that will filter out your selections. So even though I have a 36 regions right now, because I'm maintaining a data for Indian government PAN and Aadhaar, I can use only two regions, either Hyderabad or I can use Mumbai as a region where I can run my application, right? So that's there, right? What you will use, which region you will use. First factor which is there, that is governance and data residency requirement, right? Second, which is proximity to your customer. Now, since you are creating this for Indian government, which is generally accessing the resources at the central location of Delhi, right? So you have a two regions. You have Mumbai as a region, and you have a Hyderabad as a region. So what you feel, which one is closer to Delhi? Which one is closer to the Delhi, Mumbai or Hyderabad? If I take you to the map, Mumbai, right? Mumbai is the closer one. So you will use Mumbai as a region because the proximity is the closure. So latency will be less, right? So these two are very important factors. Other factors that might impact the selection of a region if it remains, one is pricing. So it might happen the price of services are different across the regions, right? Because every country has its own taxation structure, right? So if you have multiple regions to select, pricing is one factor that might impact your selection. And fourth, the availability of a service. Now, AWS has 36 regions already. And whenever AWS comes with a new service, so let's say AWS is bringing new service with the name X. So what AWS does initially, it make the service available in maybe, let's say, four regions. There are 36, but initially it will be available in the four regions. And gradually it will be spreaded to another regions, right? So service is not available in all the regions at the same time. The deployment rolls gradually across the region. So again, the service that you want to use may not be available in your region. You might need to select a different region. So these four factors will help you out that out of 36 regions, which one will be useful to you to deploy your application, right? And this region is collection of availability zone. So if I show you the regions, you can see we talked about Mumbai region. You can see availability zones. There are three availability zones. If I talk about Hyderabad, you can see there are three availability zones. So generally, you will see that every region has three or more availability zones, right? And why it is so, right? Because they want to achieve high availability. So what they did, they created the availability zone, right? So you can see this is availability zone A, AZA, and this is availability zone B, AZB in the US West. Why it is done? Now, this availability zones are interconnected with each other with high-speed bandwidth links, and they are separated apart from each other approximately 60 miles. They are kept at a distance because if the disaster happens, maybe tsunami is there, maybe earthquake is there, maybe floods are there. So everything is not down at the same time. So they are kept at a different location, which is approximately 60 miles, or we can say close to 100 kilometers apart from each other, just to make sure your services are not down, right? And maximum regions you can have in a maximum AZ availability zone you have in a region is 6, which is in the US Northern Virginia. Otherwise, 3 regions is there probably in 3 availability zones are there in every region, right? 3 availability zones are there in every region, right? So they are kept at a distance. And now when you create your services, right? So you create your EC2 machine, create your 2 copies of EC2 machine, one in one AZ, another in another AZ. What the benefit you get? High availability. Let's say this is a region that AZ which is down due to floods. Still you can serve your customer because one machine is running in the another AZs as well. So these AZs are designed to achieve high availability, right? These AZs are designed to achieve high availability there. Okay. Yes, Zafar.
So is a AZ not equal to a data center? See, I am from Northern Virginia and I see a lot of data centers over here. If you
Exactly.
know, so is that not one data center?
No, it can be one or it can
Then,
be more. It is not disclosed to the customers. So collections of data center is availability zone. So it might have one or more that is not disclosed to the customers that what AWS manages, and collection of AZs, right? Collection of
yeah.
AZs is your region. That's how it's been organized.
So the distance between two data centers could be less than 100 kilometers, right?
Yeah, it's up to 100 kilometers they have kept by doing the analysis, right? The climatic condition. Based on that, they
No,
kept
but that
that
is for
distance.
AZs. That is for AZs. For data centers, there could be less than 100 kilometers,
So
correct?
for data centers, they are probably in the same region, in the same area. One or two or three data centers they might have created there.
Uh-huh. Same
Right?
physical area, I mean. Okay.
Yeah, in the same physical area they will be there.
Yeah,
Okay.
correct.
So you can see one of the machine is down in one of the AZ, another machine is running in another AZ. So you can achieve the high availability by deploying your resources across the AZ. That's a benefit that we get. Nayan Shah, another zone will be switched automatically. No, zone will not be switched. What I will use in this particular case, load balancer. That will help me out to distribute the traffic across the machine. So I need to make sure that I'm running two machines to serve the customers. If one goes down, still another is available. So that's a load balancer that will take that responsibility. So you need to run multiple copies of machines at the same time. Yes,
So
Shubham.
this load balancer is not the same as disaster recovery, right? It is different service.
We talked about load balancers of already in the last module. It's a service
Yes.
that is used to distribute the traffic,
No, no.
right?
Yeah. But it is not a disaster recovery tool, right?
It's not a disaster recovery service. It is only a service that handles the distribution of traffic and the health of instances. If it is not healthy, don't distribute the traffic. So I can plan disaster recovery if I want to manage. If I want to manage the recovery within a AZ, I can do that.
Okay.
With load balancer. If you want across regions, again, we have other service that can help us out there.
Got it.
Okay. Right. And this was with respect to the AWS services that you can access. Now, of course, you have a customer who will use your services, right? You will have a customers around the globe that will use your services. So we can make a use of edge locations in that case, right? What edge locations does for us? Let's try to understand again with the analogy. So if I have a coffee shop through which I'm serving all the customers, it might happen this customer get the coffee in 1 minute, this customer get the coffee in 20 minutes. So different is the latency depending on where the customer is, right? And I want to make sure every customer should receive a coffee in 5 minutes, not more than that. That is what I want to achieve. So how I can achieve this? I can create multiple outlets for my coffee shop, right? And in this way, I can guarantee that a customer can receive a coffee with a lower latency, right? This is what Zomato or your Swiggy also does when you place the order. They have an area that is covered in which the delivery agents deliver the services. So you get your order in 10-15 minutes, right? So they create a content delivery network, which is basically the goods that can be delivered to the customer in the shorter period of time, right? So in case of IT services, right, we want to provision the data to the customers, right? And what I can do, I can cache the data, right? I can cache the data, right? I can cache the data at different locations. I can cache the data at different locations. And where we cache this particular data? At the edge locations. So here you can see the edge locations, right? And I have a movie clip in one of the region and customer is asking for that movie right from a different region. So of course, movie can be directly delivered as well, but it will have a higher latency. So what I can do in that case, I can cache the copy of the movie at the edge location as well. So what will happen, because I have a copy of a movie here as well, customer will be able to access the data with a lower latency. So edge locations are designed for the customers who is using your application, who is using your services, so that they can access the services at a lower latency, right? They can access the services at a lower latency. So that has been designed. And if you want to deliver the content to the customers by caching at the edge location, the service that can help you out is CloudFront. So CloudFront make a use of edge location to cache the content so that your customers can access the data at a lower latency, right? And many customers are utilizing this. If I had to quickly show you one architecture, Geo7, a case study. I'm sure you are aware of the 7 app of a Geo, which is available, right? So why it is taking me here? Just a second. Okay, I think probably they have changed the page. Just a second. Let me go back. CloudFront customer. Right. If I quickly go back. Right. I'm sure you heard about the service Savan. That is a music app right from the Geo, right? And it utilizes CloudFront, right? Amazon CloudFront it utilizes, and it delivers 15 petabytes of music and videos, right? Data of audio and video to the customers of size 15 petabytes every day. So it has a customers across the globe, and they watch the audio and they watch the videos, right? They listen the audios and watch the videos on the app, and they deliver that at a lower latency. How? Because they cache the data at the edge locations, and they are able to deliver that to the customers at a lower latency. So that's the beauty that CloudFront provides you by making a use of edge locations. Is the idea clear, team? What benefit edge locations brings to you? Okay, so I'll bring this video. I'll copy this link address. I'll share this with you. If you want to see that how customers are utilizing this, you can definitely watch that particular video for you. It's not only this. We have Shua Music in Brazil. We have Net Media Works. A lot of them are utilizing to serve the data to the customers at the lower latency. Even Prime Video that you have a service from the AWS, Amazon, they also utilizes the CloudFront to distribute the content. Right. So that's a beauty. This you can achieve, cache the copy of a data closer to the customer, reduce the latency. Right. Apart from that, we talked about end user who want to access your application. Now let's talk about the user who has a residency requirement. Right. So let's try to understand again this with the help of copy shop. So this is my organization, right? And in my organization, the employee gets 10 minutes break, right? That we had. I'll just take that analogy there. And coffee shop from the organization is at the distance of 7 minutes, right? So they require 7 minutes to go, and they require 7 minutes to come back. So approximately 14 minutes they will consume to at least get the coffee they can drink on the desk. Now, what is the problem here? The break is 10 minutes and employee required 14 minutes to get the coffee, right? And I see that the employees are not able to reach on time. That's a problem. So what I can do in that particular case, because latency is much more in this case. So what I can do, I can open a cafe in my organization itself. Now, employees can have a coffee within few minutes in the organization itself. And the same kind of feature AWS provides you in terms of AWS Outpost, right? So AWS says that if you feel the region in which you are running your services, so I have a region with availability zones, and you feel the latency is much higher for accessing the fundamental services, compute, network, and storage. No problem. Hey, sorry, team. I think again I had a network glitch. Am I audible, team?
Yes, you are, Kamlesh.
Yes, now you are audible.
Yeah.
Yep.
Thank you. Right. So what AWS says that if you're not happy with the latency that you have for the services you are trying to access, if it is more latency, you have a data residency requirement. You want to access the services at a lower latency, right? At a lower latency, right? You have a data residency requirement, and you need lower latency to access the services. So what AWS can do, it can install a outpost service, right? It can bring an outpost rack, right? So AWS can come and can install a rack of server in your own on-premise data center. And once they install this rack of server in your on-premise data center, you can run the services in your on-premise data center. So you can run an EC2 machine on the outpost. You can run the RDS instance on the outpost. So you can run the services in the outpost rack of a server. So that's a beauty that you get with the outpost. So now you are able to access the services at a lower latency with the help of AWS outposts. So AWS can come and can install the infrastructure in your location itself so that you can access the services at a lower latency. So it is trying to reach as close as possible to the customer so that they can serve the services at a lower latency. So this is what Outpost provides you as a feature. Yes, Anil?
So in this case, who will taken care by the infra of that particular day?
Anil, your voice is not clear. If you can speak a little louder.
Hello. Yeah, hello.
Yes,
Now
Anil.
it's better? Yeah.
Yeah.
So in outpost case, who will be taken care of the infra of that particular rack?
So AWS Teams comes and set up this for you, and they make sure it is running. In case if something goes wrong, they can help you out there.
Oh.
Right? So if you have that requirement, you can run it on premise. Yes, team.
Let's suppose if any hardware got failed, at that time we need to support AWS team or AWS team will help us in this case.
You can raise a customer support to the AWS. They will help you out in that case. Okay. Fine. So we talked about the selection of a region, right? What are the factors that we should consider already? So I'll just move from away from this particular slide. We talked about global infrastructure. We have a region. A region is collection of availability zones, right? And to serve the customers at a lower latency, we have a edge locations, right? So that's, we talked about global infra already. And let's talk about accessing AWS services. Okay. Yes, Marco.
Hi, Kamlesh. Can you please go back to the previous presentation, previous slide? I'm just had a query regarding the regions. So, for example, in this case, the region is in Sao Paulo, Brazil, right? So, it is composed, or it's three different zones are, representing this Sao Paulo region. Or how do you explain that? So I have three different. Yeah, I have three different time zones, right? Sorry, three different zones for a particular region, right?
Exactly. So every region has minimum 3 availability zones, right? Just to achieve the high availability there.
Okay. All right. Got
Okay.
it. Thank you.
And the last thing, how you can interact with the AWS services, right? So of course, if I need to make a order for a coffee, I can go to coffee shop and I can place a order, or I can use my Zomato app to place a order, right? So different ways are there. You can place an order for a coffee, right? Similarly with the cloud, if you want to connect to the cloud, you have a different ways. Management console, we have already seen that I can go to the browser, right? And I can launch the resources that I can do. We ran the machines, right? So I can go to the console and I can perform the operation. So I'll just terminate these machines, right? And same thing, if I want to access the services right from the terminal, or right as a developer, I want to run some application, I want to build some application for the cloud, even I can do that. So if I want to run the command from the terminal, I can use AWS CLI. And if I want to build an application to be running on the cloud, I can use AWS SDK. So I can interact with CLI, I can interact with SDK. I'll quickly show you an example where I interact with the services from a CLI, right? So I'll quickly take you to the console. I'll go it into Windows RCMD, right? So this is my terminal, as you can see. I'll just increase the font size. I'll get into a service S3. Here you can see the 3. I can see the list of the buckets in my S3 service, what buckets I have. And same list I can see on my terminal as well, right? So here you can see the bucket that I have in my account, which is around 79 buckets. I can see the list of this bucket even here. I can simply do AWS S3 LS. And here you can see the list of the buckets. If I press enter, the same list of buckets you can see is also available here. So I'll just show you one option, ACC 701124. Same is here in other buckets, as you can see. So if you want to interact from the CLI from your terminal, you need to install AWS CLI on your machine. So you can see this is already installed on the machine, right? So this is what you need to install. And you can get this right from AWS. So you install this on your machine and you configure the CLI with the credentials. Okay. So I'll share this particular link. From this, you can install this on your machine, whether you have Linux, Macs, or Windows. And once you install this on your machine, as you can see here, right, you can simply configure your credentials. I can do AWS configure, and it asks me for access key ID. It asks me for secret access key. It asks me for a region, and it asks me for an output. So these 4 parameters it asks me to configure. And once I configure this, I'll be able to interact with the AWS services right from the terminal, right? I will be able to interact with the AWS services right from the terminal, right? And here you can see the access key and the secret access key that I created, right, for a demo and that I have configured on the machine. So you can see this is ending with 5E77. Here you can see it is ending with 5E77. Okay, if the screen is stuck, I'll reshare. Is it visible now?
Yes, it is, but all the
Yes.
explanation, like from past 5 minutes, if you can reshare that as well.
What, Shubham?
So it is visible now, but I think it was
Your
stuck
video,
from past
your
five
camera.
minutes.
Yep.
Okay.
So
I stop my camera and I'll do one thing. I'll try to switch a network as well. If this is running a little slow, just give me a minute. Okay. I'll just stop it now and I'll share it once more. I change the camera. Stop the camera, change the option there. Can you see my window moving now properly?
Yes.
Awesome. Great. Fine. So you can see I configured the access key 577 ending there and same is here ending with 577. So you can configure the credentials on your terminal, right? You create access key, secret access key for your user and configure it on your machine. And then you will be able to access the services right from your terminal as well. Okay. So different ways are there with which you can access your services. Management console is the easiest one. Even you can use CLI and SDK or ways to interact there. Okay, is the idea clear? And I can see a question from the Samira. What are these secrets access key used for? So these are kind of a credentials because when I interact with the AWS services, right, it should know that who is a user who is trying to perform an operation. So for that, we can create a credentials. So whichever user you have in your account, so I'll just open a user. For example, I want to grant access, let's say, to the user of HCL, right? This is a user of HCL to which I want to grant access. I can go to security, right? I'll just deactivate and delete the current credentials that I have. Right? So I can go and I can create an access key for a HCL user that I have here. So I can go, I'll say create access key for this HCL user to interact from the CLI and create the access key. And once I do that, this is the key that I can provide to the HCL user and it can use that key instead of performing operation from the management console, that user can perform an operation from a CLI. Okay. I hope it answered your question, Samira.
Is it like an identification purpose or how it is?
For authentication purpose, it is there because anyone who is sending a request, it should be authenticated. So with that access key and secret access key, the request get authenticated that it is coming from a valid user or authenticated user.
Got it. Okay.
Just like RSA or the Microsoft Authenticator, or can we imply any external authenticator to enhance it, like RSA token?
So authenticator is basically a two-step verification, right? MFA that you have that you use. That's for different purpose. This is, see, for example, when I'm accessing this console, right? So if I want to access this console, I'll just sign out. Okay. So see, I signed out. If I want to get into a console, I need to sign into the console. I need to provide a credentials, right? I need to provide a credentials to sign in, username and password. Once I provide this, right, I will be able to access the management console because who is trying to perform action, it should be a valid identity, and we validate ourselves with the help of username and password. If you are doing the same thing from the terminal, you have an access key and a secret access key. Now you can see it allows me to see the console.
Okay.
Okay. Great. So, right. So we have seen the management console already. We have seen a lot of demos. I'll go to the knowledge check. Which of the following is true for the AWS global infrastructure? Right? So zone consists of two or more regions. This is not true. Region is collection of AZs. Right? Region is collection of AZ. So definitely option B is not right there. It's option D. Okay. Awesome. What factors must be considered when selecting a region? There are four factors, right, that we should select. One is cost. One is availability of a service. And two more factors are there
Pricing, proximity
that I have
pricing,
included. Cost I have included, which is similar to pricing,
available services,
that I have added from the given
pricing,
options.
Compliance.
compliance,
Compliance, which is option A,
And proximity.
right? And proximity to the customers, right? To reduce the latency. So these are the factors that we have, four factors that we have seen. These two are very, very important, right? Yeah. Which statement best describes a CloudFront? So we have seen what is CloudFront. What CloudFront help you to achieve? Great. I can see the answer appearing in the chat right from the Deepak, right? So CloudFront help you to achieve, right? CloudFront help you to achieve a content delivery network, right? CloudFront help you out to achieve a content delivery network. Okay. And which site does the Amazon CloudFront utilize to cache the copy of a content? So where it caches the content? At edge locations. Great. I can see the answers in the chat as well, right? Which action can a cloud practitioner perform with AWS Outpost? So which action you can perform with AWS Outpost? So what AWS Outpost is doing? Great. It is extending the infrastructure of AWS at a different location. It can be your on-premise data center as well. Okay, and I hope that completes our module, right? That we have seen right now. I hope the idea is clear for this particular module. And if all is good, we can go for a short break. So all good, team? Yes, Deepak? Any query? Okay, it's a
No,
thumbs
sorry,
up, fine.
by mistake.
No problem. So I'll enjoy the short break. And once we come back, we'll cover more modules ahead. Okay, team, I am back. If you are back in session, please drop your update in chat. And at that point, I'll quickly bring the slides of the next module over the screen. Great. So I can see the back messages appearing in the chat. So if you're back, you can type a message in the chat. Yes, Selvaraj, any query?
No, I just said I'm back. Yeah.
Awesome. Great. So let's begin with our next module. I can see members are coming back. Let's begin with our next module, which is networking. Right. So you can create your own virtual network in a cloud. And when you create a network, what options you have, what features we have, we'll talk about that in this particular module. So let's try to understand again with the analogy of a coffee shop. And in this module, we'll talk about the networking concepts, how we can create a network in a AWS cloud, which service can help us out. We can have a public and a private subnets. So when we should public subnet, when we should use private subnet. Apart from that, if you want to connect our on-premise data center to the AWS cloud, right, to the networking of AWS cloud, what options you can use, right, to connect. Apart from that, we have two ways to connect to on-premise data center to the cloud. One is VPN, one is direct connect. So we'll see what's the benefit that we have, right? And we'll talk about even a little bit about security, how we can filter the traffic. Yeah. So let's begin. You can see we have Amazon VPC, we have NACL in the security group, and how we interact with the AWS global network. These three topics that we have in this module. So let's talk about again with the analogy of a coffee shop. So let's say I have a coffee shop, right? And in the coffee shop, the customers can reach cashier and customer can reach barista as well directly, right? And what is the problem if both of them are reachable, right? So one customer might bypass the cashier, directly place an order to the barista. Can you give me a coffee? Which is, I don't need that privilege to be provided to any customer to talk to barista directly for a coffee. It should be always customer talk to cashier and cashier informs the barista about the coffee. This is what is the flow that I require. So what I can do in that case, I can segregate it. I should create a cabin around the cashier and the barista. The cabin of the barista has a window from where cashier can talk to barista and customers can talk to cashier via this particular window. And this will ensure customers can talk to cashier and cashier can talk to customer as well and to the barista as well based on the order that is placed. Right. So we can add the layer of protection by creating a cabins there so that customers cannot reach the barista directly there. And same thing we can do in AWS with the help of VPC. Right. Same thing I can do with the help of AWS. And I can use a service called as VPC, which is Virtual Private Cloud. That's a service that can help us out to bring such kind of isolation for the resources. Amazon Virtual Private Cloud or VPC. So let's talk about that, right? What is VPC? VPC is a service, right? VPC is a service that will help you out to create a boundary, right? A boundary of network. So you can create your own small virtual network in a cloud, right? And this network is a bigger area. So this is my cafe. So this is a boundary of my cafe where the customers can come, right? This is a boundary of my cafe where the customers can enter and can communicate. And to make sure my cashier and barista is protected, I divide my VPC into smaller networks. So this is my subnet and this is my another subnet. So I divide my bigger network into smaller networks. This is my cafe boundary In the cafe boundary, I create two more sections, one section for cashier, one section for barista, right? I kept cashier in the public section so the customer can talk to cashier for placing an order. And since cashier is in public section, it can revert back to the customer and it can even talk to the barista because it's in the same boundary there, right? So we can achieve this kind of separation in a cloud with the help of VPC. So I can create my network in a particular region. So you can see this is AWS Cloud and within the region of AWS. So let's say this is a region of Mumbai. So within the Mumbai region, I can create a VPC. And VPC is a bigger network. I'll divide my VPC into smaller networks because I want some resources to be private and some resources to be public so that it is accessible over the internet. So I can divide my bigger network into smaller networks. So you can see subnet 1, subnet 2. This is private subnet. This is public subnet. So if you have a databases, if you have application servers, you can keep that into a private subnet. And if you have a web servers through which you are serving your customers with the service, that you can keep in a public subnet. So anything that you want to reachable on the internet, you can keep that in the public subnet. Anything that you want to protect from the public access, you can keep that in the private subnet. Right. So divide your network into smaller subnets based on your requirement, either as a public or a private where you want to keep your resources. And once you do this, you create subnets into your VPC. And to make your subnets reachable to the internet, I need to attach internet gateway to the VPC. What is this internet gateway? It's a virtual router, right? It's a virtual router that we connect to the VPC and it makes a traffic from the internet to get into VPC or any machine who want to reach internet, they can reach via this internet gateway. So it allows the traffic from the internet to get into VPC as well as any traffic that we want to send to the internet. We can send from VPC to the internet via internet gateway. So that is what internet gateway does. It allows a VPC to allow the traffic from the internet or to send the traffic to the internet via this internet gateway. So it's a router that helps us out to route the traffic outwards as well as inwards that is coming from the internet to the resources that you are running in the public sector. Okay, so we can use VPC to have the public and the private subnet, and to make the subnets reachable to the internet, we require internet gateway. To enable the communication between the VPC and the internet, we have internet gateway. Okay, is the idea clear? This much? So how we can segregate the resources into different subnet based on the requirements, and to make the resources accessible on the internet, we require internet gateway. Is this clear, team? Awesome. Going out, we have a virtual private gateway. Now, when we configure this virtual private gateway, if you want to connect your on-premise data center to the VPC, we need to configure virtual private gateway, right? I need to configure a virtual private gateway at the VPC, right? And if you want to connect your on-premise data center to the VPC, virtual private gateway is configured. But how will you connect? Either you will use internet to connect to the VPC, and if you are utilizing internet, in that case, you can make a use of VPN connection, right? In that case, you can make a use of VPN connection. What's the beauty that you get with the VPN? With the VPN, the traffic that goes from your data center to the VPC, for that, the encrypted tunnel is created. So to protect your data when it goes to the internet, we want to protect the data. So a tunnel is established between your data center and it is an encrypted tunnel. So no one will be able to access the data. It is an encrypted tunnel through which the data is moving between your VPC and your data center. So if I want to use your existing internet connection, you can use VPN connection. to connect your data center to the VPC. And if you don't want to use internet, but you want to have a dedicated fiber link, right? You don't want to use internet, but you want dedicated fiber link, right? I can say you want dedicated fiber link or you want dedicated connection deployed for your usage, right? Deployed for your usage. So you want to connect to AWS VPC, but you want your own line of connection. You want your private line of connection. So you want a fiber line to be deployed for you through which you can talk to VPC. And the service that can help you out there is Direct Connect. So if you want to connect your on-premise data center, one option is Direct Connect. Another option is VPN. VPN make a use of internet to send your data. Direct Connect make a use of dedicated fiber link, which is dropped from your location to a partner location, right? Half of the deployment is already done by AWS till the partner, and remaining half is done for you whenever you request a direct connect connection. And once this connection is established, a dedicated fiber link is there for you to send your traffic. So you decide whether you want to use internet to send the traffic with the help of VPN, or you want your personal connection to be deployed for you with the help of AWS Direct Connect. Okay, with the help of AWS Direct Connect. Is the idea clear? See? So two ways are there to connect. Direct Connect, your own link to transfer the traffic. VPN, where you make a use of internet to send the data. So both options are there to connect your on-premise data center to the cloud. Okay, so let's recall the concepts with this exercise. So I want to isolate a database containing personal information. So where I will place this database among the four options that we have on the right. So where you will place your database? In a private subnet. Awesome. So we'll add a database into a private subnet. Great. You want to create a VPN connection between the VPC of your AWS and your internal corporate network. So what you will use there, right? What you will configure there, a virtual private gateway. Awesome. You want to create a customer facing website. So the customer can access that resource and can reach your website, right? So you will keep your virtual machine on which you are hosting your website in a public subnet. Great. And if you want a dedicated connection laid down only for you between your on-premise data center VPC, you can make a use of AWS Direct Connect. Okay. So I hope the fundamentals are clear. I received the same answers in the chat. So great. Now let's move ahead. So this is with respect to the network that we can create. Now let's talk about filtering, because we have the restriction, right? So I shared the link to you. I told you to access that link. You said it is not accessible in the HCL network. Why? Because that address was filtered out and you was not allowed to reach that resource. And if you require the same thing, that you want to filter the traffic with the rules, the first service that can help you out is NACL, Network Access Control List, or we say it as a NACL. Now this service does the job of filtering the packets. Right? This service does the job of filtering the packets, and this filter the packet at subnet level. So any traffic that is entering the subnet, any traffic that is coming out from a subnet, right? So any packet that enters your subnet and any packet that leaves your subnet will be evaluated, right? Will be evaluated by the NACL, whether it is allowed or not. So we can add the restrictions by defining a rule in the NACL, whether to allow a particular packet from a particular IP at a particular port. So I can do the filtering of traffic at the subnet level with the help of NACL, right? So it's again a virtual firewall. for a subnet, and by default, the NACL that you have, right? By default NACL that you have, it allows all inbound traffic. So any traffic that is coming in, it will be allowed, and any traffic that is going on, that is allowed. So default NACL that you have, there is no restriction. If you want to put restriction, create your custom NACL and specify the rules, what you want to allow, what you want to deny, that you can configure. Okay, so I'll quickly show you that example of a NACL. So if I go back here to VPC as a service, right? There you can write a rules. So I'll quickly go back to the NACL, right? And here you can see the NACL. I'll just open this particular NACL that I have, right? And here I can edit the rules, right? So I can write a rule, let's say with the number 120. What traffic you want to allow? I want to allow HTTP traffic, right? Port 80 is mentioned. From which IP addresses you want to allow a traffic, or from which IP addresses you want to deny it. So I can write a rule in that way to allow a traffic or to deny a traffic from a particular IP on a particular port. That rule you can specify in the NACL. So this is what's been configured to apply the filtering at the subnet level, a NACL that can help you out in that case, right? So default network allows all inbound traffic. So the NACL that I have shown you, which is a default NACL, you can see rule number 100, all traffic is allowed from everywhere. So that's my default NACL. If you want, you can create your custom NACL as well. So by default, everything is allowed. Okay, and if you want to configure, you can configure a custom NACL, or you can add your own rules as well for the same. So it's a filter that filters the traffic at subnet level. And similarly, we have a security group. And what the security group does, it filters a traffic at instance level. So to the EC2 machine, I can attach a security group. And what the security group will do, it also filters a packet. So what packets are allowed to come to EC2 and what packets will go from EC2. All of them we can control with the help of security group. So this also acts as a firewall, virtual firewall that you have, and this works at instance level. So I have two options to filter. To filter at instance level, security group, and to filter at subnet level, we have NACL. So you can control the traffic with the help of NACL and the security group. You can apply the filtering rules for the same. Okay, is the idea clear for the NACL and the security group? And I
Can
hope
you please explain the security group again?
Okay, so security group applies the restriction at the instance level. What traffic you want to allow to reach instance, and what traffic you want to allow the instance to send, that you can control with the help of security group. So I can filter the packet before it reaches the EC2 machine. And also I can filter the packet that EC2 machine is sending to someone else outside. So I can do the filtering packet that is coming and going with the help of security group. The way the NACL was working, same as we have security group, but this work at machine level and this works at subnet level. Okay, is it clear now?
Yes, of course. Thank you.
Thank you. And Zafar, let me know your query. I think your hand is high.
Yeah, so I wanted to know what is the security? Is there a security at the load balancer level?
We have a security group at the load balancer level as well. So when I configure a load balancer as well, so what traffic should go to the load balancer, that also we configure, right? So if I...
And that would be a security group, not a NACL.
No, that is a security group, definitely.
Oh, okay. All right, got it.
Okay, fine. So I'll just skip this part, right? And one more thing, security group is stateful. Right? Security group is stateful and NACL is stateless. Right? NACL is stateless and security group is stateful. Right? What that
What
means?
does that mean?
Yeah,
Yeah,
I'm coming
sorry.
on that. What that means. So we know that we send a request and we receive a response. Right? We send the request and we receive the response. So security group always inspect the request. So as a client, I send a request to EC2. So I send the request. So this request will be checked by a security group. Right? This request will be checked by a security group, whether it is allowed or not. Right? And if it is allowed, security group will send it to EC2 and EC2 will provide me a response. And when the response is coming, when the request packet is coming, it is evaluated. But when the response is coming as a part of a packet, there is no need to evaluate this. So this is not getting evaluated because security group remembers that the request is already evaluated by me. So it is okay if the response is going for that particular request. So security group is stateful. It remembers that the request is already processed, is already checked. It is a response that is going out. So that is statefulness of a security group. Only requests are evaluated. So if someone is sending a request, that will be evaluated. And same is there for EC2. So let's say if EC2 is connecting other service on the internet, right? EC2 is sending a request. Then this will also evaluate it. But when the response is coming back, there is no need to evaluate the response because request is already evaluated by the security. So that's the beauty of a security group that we have. It remembers the request is evaluated. This is the respective response. No problem in that. Whereas NACL is stateless, right? If a packet is coming up, it will evaluate. If a packet is going out, it will evaluate. Doesn't matter whether it is a request coming in or whether it is a response going out or a vice versa. If a packet is entering, it will be evaluated. If a packet is leaving, it will be evaluated. You don't remember that this was the request, this is a response for the same because it is stateless. Okay, is the idea clear? Okay, and the last thing that we have, interact with the AWS global network, right? Now, when you run the resources within AWS, right? So how the customer can reach that AWS resources because it is running within AWS. So how you can reach it. So to help you out, in that case, we have a DNS. What is DNS? A domain name system. So whenever customer sends a request for any service, right? We say, I know that a server is running. So I have a EC2 machine on which a website is running. Right? This EC2 machine has IP 1.2.3.4. And which website it is running? Let's say I'm running www.techm cpe.com. I'm running this particular website, right? So if a customer sends a request for this www.techmcpe.com, first DNS will resolve that domain name and it will return an IP address to the customer that to forward a request, send your request on 1.2.3.4. And then you reach actually your server, right? Now you are running your services inside AWS and the service that help you out in resolving the domain names to a particular IP or to the particular destination. The service that we have is Route 53 in AWS. That is managing the DNS request of your resources. So if I'm running a server for www.techmcpe.com, if I send a request for this DNS, right? The DNS server of Route 53, which is running as a DNS service, that will tell me that for this domain name, send a request on 1.2.3.4. So this is what it is doing. It is resolving a domain name to the IP addresses. So the workload that you run, you can assign a domain name to that workload, and this Route 53 will do that for you. It translates a domain name to the IP addresses for the workload that is running in the cloud. That's a beauty that it provides you, right? So any service that we have on the internet, the request always go first to the domain name server and then it get resolved. And for Route 53, DNS is working as Route 53 is working as a DNS service, right? So if I do ping, let's say amazon.in, you can see I said I want to ping amazon.in, but it is sending a request on that particular IP. Reason being the domain name is translated into IP. And that's what the service that uh, uh, Route 53 provides you. So any workload that you are running within AWS, you can connect that workload to the customers via Route 53 as a DNS service. Okay. See, and here you can see if a customer is trying to talk to a domain name which is in the CloudFront. So first a request is sent to the Route 53, then it goes to CloudFront. And in case if you have a load balancer behind CloudFront, we'll go to the load balancer. One of the machine will serve your requests and you get a response back. So to how to reach the resources running inside AWS, this Route 53 service can help you out in resolving the DNS for those things. Okay, so that's a service that we need to configure as well to make our resources available over the internet, right? Or to map our resources to the custom domain names that you have, so that via that custom domain names, you can reach the resources running in the cloud. This is where Route 53 helps us out. Okay, is the idea clear? See, any query? Great. So which component or service can be used to establish a dedicated connection between company data center and AWS? Right? So dedicated connection we require between company data center and AWS, that is direct connect that we have seen for connecting your on-premise data center to company, which is there to AWS VPC. Direct connect, a physical fiber line for you is laid down so that you can transfer your data. Which statement describe the security group? Which statement describe best the security group? Great. So it's stateful and by default nothing is allowed. You configure what traffic to allow. Stateless is NACL, so definitely this two option goes out of picture. Remember, NACL is stateless and security group is stateful. So it could be from option A and B. By default, everything is denied as inbound traffic. You configure what traffic to allow over the EC2 instance. Okay. Which component is used to connect VPC to the internet? So if I want my VPC to have internet connectivity, which component is there? Great. So I can see option A, that's right. It's internet gateway that I require to be attached to my VPC so that instances, resources in my public subnet can reach the internet. Okay. Which service is used to manage the DNS records for the domain name? So which service can help us out with DNS solutions? Awesome. Route 53. Okay. So that's the correct answer. And which statement does describe the DNS resolution? So we talked about the DNS name gets resolved. So which statements describe that? Great. Translating a domain name to the IP address. We have seen the demo as well. I sent the request on amazon.in and we got the IP address. That's what is DNS resolution. And that completes a module of networking that we had to have an idea how we can control the access to the resources, how we can filter the traffic. I hope you got the insights for the same. And We have a last module for the day, and then we'll be ending our session, right? And once we complete this module, right, I just need one favor from your side, right? When we complete this module, right, what I need feedback. You can write in chat, right, about the session. How you felt the session was. So this you can write in chat, right? A feedback about the session in 1 or 2 lines. You can write that feedback for the session, right? Okay. So let's begin our module number 5. Yes, Ajay, I can see your hand is high.
Yeah, tomorrow it will be the same session again, or it will be some different session on it?
It will be the same session conducted by me with different modules.
Different modules will be there. Huh?
Exactly.
Means we will going to forward means module 6 to 7, 8, 10 up to like
6,
that.
7, 8, 9. 4 more modules are there. 10th is for exam part.
Okay.
Okay. Great. So let's move ahead with module number 5, which is talking about storage and databases, right? So in this, we'll talk about AWS storage. We'll talk about AWS databases, and AWS provides us various database products, what benefit it brings to us. Okay. So let's move ahead. Let's talk about storage, right? Now, when we talk about storage, storage has different types, right? And we have a block storage, we have a file storage, and we have right. So different kind of storage requirements are there, and the prime difference between the three, block storage is similarly to your raw storage. So you have a hard disk, right, which is divided into tracks and sectors. Similar to that is block storage, the raw storage, where you can install the OS, you can run the databases. That's a block storage. You have a file storage as well as a solution. So in your organization, I'm sure you might have a common storage location, right? A common storage location where members share the content, right? Or I can say SharePoint file server that you have. All of you share the files at the common location. That is a file storage solution. And if you want to store your data and its metadata as well, you want to preserve the state of data and the metadata so that both of them is kept intact. In that case, you can make a use of object storage, right? So AWS provides solution for all three storage types. So the first one that we have, block storage as a solution. So if you want a block storage, a raw disk to be used for storage purpose, the solution that is given to us is with EBS. So when I launch a EC2 machine, so I have shown you that I launched a EC2 machine. So if I quickly go back to instances, I will launch an instance. Okay. So I'll not launch an instance, but I'll show you that particular option available there, right? So I launched the instance quickly, but if I go back here in the storage settings, you can see a volume is available, right? A 8 GB volume is connected to my virtual machine in which the basically the OS get unpacked. If you want to have more volumes, more drives for your machine, you can add more volumes as well. These are nothing but the EBS volume. What is EBS? It's a elastic block storage, right? It's a elastic block storage, right? So a volume of storage, right? A volume of storage, whatever size that you mentioned, is connected via network to your EC2 machine, and you can store your data in a persistent manner in EBS volume, right? So it stores persistently your data. Whether you stop or terminate your machine, right? Whether you stop machine as well, your data is persisted because it stores your data permanently there until unless you delete explicitly there. So that's a EBS volume that get connected to the machine when you launch the EC2 machine. Apart from that, one more kind of volume that you can connect to your machine, which is instance store. Right? So we talked about that we have a physical server, and on that physical server, we have a hypervisor, and here we create our VM, our EC2 machine on that physical server. Now my physical server also has a storage, right? My physical server also has a storage. If I want to use this storage, right, this part of storage for my VM, right, I want to utilize part of storage for my VM, then we say that the volume that is attached to the EC2 for the usage is instance store. So this is a storage right from the underlying physical server. It is not the network attached. It's on the same machine where your virtual machine is running. So what's the benefit? You get more IOPS, more read and write facility with an instance store. But this instance store comes with a caveat. It do not persist data, right? It do not persist data, or I can say it provides you temporary storage, right? So if you want to store the intermediate values of processing for quick read and write, you can use instance store. And this is a storage right from the underlying physical set, right? Which you can, where you can perform read and write much faster. So that's a beauty that you get with the instance store. But it comes with a catch. It is for temporary storage. It do not persist your data. So if you want to persist the data, use EBS volumes. If you want higher read and write capacity for the temporary purpose, you want to write some data, you can use instance store as an option for your EC2 machine. And this is only available with few set of EC2 machines, whereas EBS volume is available with all EC2 machines. Any EC2 machine you launch, it will have a EBS volume, but instance store is only available with some set of machines, not with all. Okay, is the idea clear? For the block storage, two options, EBS and instance store. Similarly, here you can see EBS volume, here you can see instance store that we have spoken about, right? So this persists your data. Moving out, object storage. So if you want to process the data along with its metadata, we can make a use of object storage, and the service that provide the object storage solution is S3. Right? Now S3 is again a serverless service. We don't need to create any server for S3. We can simply go to S3. Right? I can simply go to S3. Only thing that I have to do, I need to first create a container, which is S3 bucket. And once I create the S3 bucket, I can store the objects inside that, the data inside that. So you create a container as a bucket and you store your data into S3. Of course, you can control who can access the data, how long you want to preserve the data. But the benefit that S3 is bringing to the customers, that S3 provides you different storage classes, right? S3 provides you different storage classes, right? And what is the benefit of the different storage classes? The benefit that we get, we can save the cost, right? We can save the cost, right? So depending on your excess frequency, at what frequency, right? Excess frequency of your data, at what frequency you access your data, based on that, you select your storage class. So if there is an object, if there is a data that you access regularly, store that in S3 standard. if you have a data that you accessed only once a month, right? If you have a data that you access only once a month, store that in standard I, because the cost of storage is lower with standard I compared to your standard. So if I draw a line, here the cost is lowest and here the cost is highest, right? Per GB storage cost which is there. So based on your access pattern, decide which storage class is useful for. And you also have S3 one zone IA to help you out in this particular case, right? So that's a beauty that we have, and there is a blackout on my side. Just give me 1 second to switch the network. So I just switched the network, and just give me 1 second because there is a blackout. My screen is also not working. I'll just use my single screen for the explanation there. And let me know if my screen is visible. Okay, team, is my screen visible?
Yeah, it is visible.
Awesome, thank you. So we have different storage classes and we can save the cost based on access pattern, right? So I'll quickly go back to the S3, right? And what I can do for the reference, right? When to use which storage class, right? I'll quickly share a small table with you that can help you out. So let me just minimize this. I'll say upload a file. And when you upload a file into S3, when you upload a data, you have a storage classes here, right? You have a storage classes here that you can utilize. So I'll just do control minus to minimize this. And I'll take a snapshot of this and I'll share this here in the chat. So these are the storage classes we have. Okay, and I'll share this in the chat for the reference as well. Right, and I'll use the same in the whiteboard here for a minute. Okay, so here you can see when you go to the S3, you try to upload a file, you can see if it's a file which is accessed more than once a month, go with standard. If you have a file which is accessed only once a month, not more than that, go with standard I. And cost is highest here and cost is lowest here from top to bottom. So based on your frequency pattern, select the storage class. You can have one zone IA, again that you can give you the lowest cost. Why so? Because one zone IA replicate your data in a single AZ. Okay, you can see zones in which your data gets replicated, right? Zones in which your data get replicated. So S3 is a durable service. Whenever you upload a file in S3, so that's my S3 bucket. And as a client, let's say you uploaded this object in S3. What S3 will do within a region, so let's say the bucket is in Mumbai region. What S3 will do, it will replicate this object across the availability zones just to make sure your data is highly available, right? So S3 is a service that provides you the durability of 11 nines, which is 99.9999. That's a durability it provides. Why it happens? Because S3 has a serverless service behind the scene. It creates the copy of your object so that if even one of the AZ goes down or even two of the AZ goes down, still your data is available to you because the multiple copies are created for the same. So that's a durability that S3 provides you. So if you are okay with less durability, go with one zone IA, which creates in a single AZ. So those three classes we have on the first screen: standard, standard IA, right? Standard, standard IA, and one zone IA. So that you can select, or you can select other storage classes, right? So if you want to store a data for a compliance purpose, right? So we know that banks stores the data for the last 5 years. So at any point of time, you want to get the data of the transactions that you did 4 years ago or 5 years ago, they can still provide you. So if you want to store the data for the archival and the compliance purpose, you can use S3 Glacier as a service. So any data that you want to store for longer period of time, right? For archiving or for compliance, right? You can use S3 Glacier. It also comes in 3 flavor. Here the cost is highest, right? And here the cost is lowest. In the Glacier as well, you have 3 options there, right? And definitely the cost of Glacier is much less than the classes that we have seen before, right? And you decide which class you want to utilize. The only difference is in the retrieval time. So if you use Glacier instant retrieval, you can get the data in few seconds. You will start receiving the data. If you go with flexible retrieval, it will take few hours to provide you the data. And if you go with Glacier Deep Archive, it will take up to 12 hours to provide you the data, right? So based on your storage class, right, based on your frequency pattern, you decide which storage class can help you out. And if you do not know that whether the data is used regularly or whether it is not used regularly, I don't know how it is being accessed. In that case, you can use another storage class, which is intelligent tiering, where AWS takes the responsibility of moving your data to other storage classes, right? AWS takes responsibility to move the data to different storage classes, right? So AWS monitor the object when it was accessed, right? And based on that, it decides if it is not accessed for 30 days, move it to standard I. If it is not accessed for, let's say 90 days, move it to Glacier. So it automatically moves the data to different storage classes by monitoring your objects. So if you don't know the access pattern, how the data is getting accessed, use intelligent tiering, where AWS takes the responsibility of moving your data to different storage classes based on how your data is getting accessed. So that's the beauty you have. You can save the cost. And when I'm saying you are saving a cost, right, you can see that if I quickly go back here, I can say S3 customer stories. Right? And in that service, here you can see, if I talk about cost optimization, right, you can see Zolendo is saving 37% cost in annual storage, right? 37% annually they are saving in the storage cost, right? Not only Zolendo, how it is saying, by making use of intelligent tiering. Teespring is also saving the cost, right, which is 30% on its monthly storage cost by using Glacier. So if you don't know the access pattern, use use intelligent tiering that can automatically move your data to different storage classes for you. So remember this fact based on the access pattern, select the storage class, right? So, and how frequently you want to use, based on that you select. If you want to keep it for a longer period of time, use Glacier. And if you don't know the access pattern, use S3 intelligent tiering as your storage class. Okay, team, is the idea clear? Yeah. The most expensive is S3 standard and the most cost efficient is Glacier, but that is for the longer duration. Okay, Marco. And moving out further, apart from this S3, which is a solution that we have, if I go back, so you can see a quick knowledge check. You want to store data that is infrequently accessed, but must be immediately available when needed. So they said it's infrequently accessed. So which storage class you will use in this case? Right? So they are mentioning the data is not accessed frequently. So which storage class can help us out in this case? Let me see the answers. Correct. I can see the answer appearing as C and A both. The correct answer is C because they know that it is not infrequently, this is not accessed frequently. They're mentioning it. If they don't know the access pattern, right? If you don't know access pattern, then you can go with intelligent tiering. Here they know the access pattern, it is not accessed frequently. So I want to save on cost. I can go with standard I. Okay, is the idea clear? See? And moving out further, we have a file storage. So if you want to share a common location across multiple machines, as I talked about, we have a SharePoint. In the similar way, in the AWS, if you want a common storage solution to be there, you have a service called as EFS. Right? Again, EFS is serverless. I don't need to create any file server. This is serverless. Just create your EFS service. And once you create this EFS service, which is scalable and serverless, you can provide that common location that you created in the EFS to the thousands of servers. So thousands of EC2 instances can access this mount, right? They can access this storage location by mounting on EC2 machine. So any EC2 machine who want to access this location, they can mount this EFS volume, right? They can mount this EFS volume and they can access the common location across multiple machines, right? They can access the common location across the multiple machines. So that's the beauty this file system provides you, where you can share the content across the multiple machines. Okay, so that's a beauty that we have with EFS as a service. And let's talk about the databases, right? I'll see that there are only 2 minutes. So is it okay, team, if I extend the session by 3-4 minutes? Let me know. Or if you want, I can even continue that tomorrow as well. Okay, great. So I can see yes from the Nayan. Sure. So just give me 2-3 minutes. This module will be done for us. And then we'll start with the fresh module tomorrow. So let's talk about the databases, right? So we have two kind of databases. We have relational databases. We have non-relational databases, right? Relational databases are our MySQL or Oracle or Microsoft SQL Server, Postgres, right? We have different database engines available to us. This is the most popular databases that every customer who is running the IT services, they have this database there in behind one or other application. But this databases has limitations as well, right? And limitation is in terms of number of read and writes it can provide, because these databases support join operations, and due to which the complexity is higher and they can scale up to certain number of read and writes. That's a problem that we have with the relational databases, and due to which the non-relational databases came in action. These non-relational databases store the data in different formats. It can store the data in the key value format. It can store the data in the document format, right? So depending on what kind of data base you have, they have a different storage format for the same. So based on a requirement, whether you want relational or non-relational databases, how many read and writes you want to support, you select your database, right? So relational database, we know that if you want to query the database, we can use the SQL language to query our database. We can use select statements, insert, update, delete, right? The standard statements that we have that we can use with relational database to extract the data. And AWS provides this RDS service with different database engines, right? And I'll quickly get you to the console and I'll quickly get into RDS just to show you that what different engines AWS provides to you, right? So if I quickly get in there and databases, I'll say create the database, and you can see the different engines for the database available from AWS. MySQL, Oracle, MariaDB, Postgres, Microsoft SQL Server, IBM, all these engines are there. And two more engines you can see, Aurora MySQL compatible, Aurora Postgres compatible. Now, Aurora is AWS proprietary solution. It's an enterprise ready database that AWS offers, right? So you can see the database engines, and Aurora, as I mentioned, it's a AWS proprietary database solutions that we have. And AWS promote this database because it's a database that is being optimized and it's an enterprise ready database with us, right? What they did, they optimized the database, they reduced the IO operations, and it increased the durability of your data. How it does that? So whenever you store the data in the RDS, which is Aurora, right? So as a client, I write this item X into Aurora. What Aurora will do, it will write this item X in a particular region. So this is a region. I have AZs. So this item X, it will replicate across the AZs and it will manage 6 copies of this particular data, right? And what is the benefit of having 6 copies across the multiple AZs? The durability that you have, that is increased, and as well as your IO operations are reduced. So you can read a data from any location, any AZ without any problem. So that's a beauty that we have with Aurora, right? That's a beauty that Aurora provides you, right? So that's a solution right from AWS you can use for your RDS, and this is compatible with MySQL and Postgres, right? And apart from that, we have a discussion. So an employee at a coffee shop says that they want to manage a inventory. So to manage the inventory, what they should use? They should use a text file where they can write the inventory and store that into S3, or they should use other service, maybe RDS or other database service that is available. So what do you think? To manage the inventory, what you will use? A text file or a database?
Database.
Exactly, we'll use other services there, right? And other kind of non-relational databases we talked about, I'll bring one kind of non-relational database, which is DynamoDB.